let me take you to what is the, the agentic core layers. Okay. Now, yesterday, whatever you learned, that is done. Okay, that part is completed. Now we are learning freshly some more new architectures, a new perspective. Like we will try to understand what exactly it is. Okay, and we will learn it in a very, very simple way, like how we have learned yesterday to understand different scenarios and all. See, always remember one thing. What happens is you will always have a user. Okay, why we need a user? User actually sends the input everybody. Okay, so user basically is going to give a command. Okay, user is going to give a command or user is going to ask a question simply. Okay, so user is the one who is going to either give a command or user is the one who is going to ask a question. For an example, the user will say to AI agent, hey, book me a meeting at 4 p.m. Anything, any request it may be, like whatever it can be, the user who can give a command or can ask a question. Then once the user provides the input, right, input can be anything, like as I said, command it may be, or it may be related to question, anything it may be, it can actually be. Okay, now what is going to happen, the AI agent, okay, the AI agent which is present right now, the AI agent will now go through three important layers, everyone, based on the whatever the user has asked as an input. Okay, based on the, let's say, the user, whatever the input they have been able to ask, now that will be going through first of all AI agent. Now AI agent will say, now I am going to take this input from the user and I'm going to take that into three different layers which I have within me. As an AI agent, I have three important layers present within me, everyone. So one being your perception, another one being the cognitive, third one being the action. Let's understand what is going to happen. Okay. First, perception means what? Perception here means, okay, perception means here understanding the input, everyone. Okay, perception means understanding the input. Like whatever the user has asked, until you don't understand that input, what is that you're going to do then? Right, it's a very basic thing is, if somebody is asking me something, then first of all my responsibility is to first understand what they're asking to me. Forget about whether I'm giving a right answer or a wrong answer. First thing is, if you are asking me a question, I should have every right to understand what is your question first of all, and that is what is a perception layer. In the AI agent, you have a perception layer. This perception layer will try to understand the input. So basically the agent will try to read, hear, or sense what exactly the user has been able to say. And then it can handle different types of input, everyone. It can be text, or it can take the image, or it can even consider the voice. Okay, that is a multi-model we call it as. Okay, like tools like, let's say, sensors or maybe like media inputs, it helps it to gather information. So what I'm trying to say is, as AI agent, the very first layer is a perception layer here. In the perception layer, what you can do is you can understand the input. Okay, you can understand the input. The moment you try to understand the input, right, so then it will take it further. So input can be anything. Perception says that you can give me input in any of the way. I have the capability to understand you. Like you may give me the input in the form of a text, I can still understand. You can give me the input as an image, I can understand. If you give me the input as a voice, I can still further understand. Okay, so those are what, like you can multimedia, sensors, multimodal means it says that perception does not say you that you give me only text, I can understand that. It never says like that. It says you give me anything in the form of a text, image, voice, okay, or you try to give me like you use the tools like sensors, or you use the tools like multimedia inputs. Okay, any way you give, I will hear and I will try to read whatever the request you are providing to me. That is the capability which I have within AI agent as one of the layer called as perception. So perception means I understand you, whatever input you give me, I try to process that, and then I take it further. Now, however you give input, that's up to you. I have the capability as a multi-model to take up text, to take up image, to take up voice, and I can be able to proceed further. Is what we are trying to refer to here as a perception endeavor. Okay. Then Once it understands the input everybody, in any way it can be like a text, image, voice, okay, whatever the input you give, then comes the cognitive layer, everyone, the second layer in the AI agent. What is a cognitive layer? Cognitive layer is where actually all the thinking and then all the deciding is actually going to work upon everybody. Okay, so cognitive is a layer where you see that there will be good amount of thinking, there will be good amount of deciding which is going to happen. So what is going to happen is, cognitive is where the agent will use its memory, okay, that is past conversations if it has done till now anything, and then it will use its knowledge, which is like facts, rules, whatever it has been able to learn. Then it is going to make a decision that what should it do based on the input whatever the user was able to provide. Let's say the user said that, for an instance, as I said, the user says to AI agent, hey, book me a meeting. Okay, book me a meeting at, let's say, 6 p.m. Okay, so let's say book me a meeting at 6 p.m. Now, cognitive layer, for first of all, from the perception layer, it understands what the user is asking, and in the cognitive layer, it will think and then it will decide. So, how it will think? The agent will use its memory, like any past conversations which are related to it has happened, and it will use its knowledge, like all the facts, rules, and everything. And finally, it's going to take a decision like what it should basically do based on the input which we have been able to provide. So let's say it decides ultimately to schedule the meeting at 4 p.m. because at or 6 p.m. because at that time we are actually free. So it will take the decision to schedule the meeting based on whatever the user has been able to ask for. That is a cognitive layer where thinking and deciding is going to happen. And finally, the action layer, everyone. So action layer is where ultimately we are actually trying to do the task. Okay, like here is where we are actually going and doing the task. So now the agent ultimately will now perform the action in the real time, everyone. So it may be like whatever you asked, like either if you asked for booking the meeting, or either if you have asked for sending a reply, or either it may be like you want to show the result, whatever the user has asked as an input, that action is going to be taken up in this particular step, which is the final step. Okay, and it also, it will anyhow take the action in the real time whatever you asked for, and on top of that it will also monitor everyone. It will also monitor the result to make sure that the task is done appropriately. So it books the calendar event for you and also gives you the confirmation. It's not like it will book it and then set it idle. No, it will try to book the meeting if you have asked for, and it will also give you the confirmation that, hey, I have completed my job. So you can please go ahead and then try to see that I have confirmed, I've given you a notification so that you can proceed and can join at that particular point of time. Okay, so whenever the agent is doing the action, the agent is going to go back and give you the result or the answer to the user ultimately. Okay, then only the cycle is said to be fully completed. So what is happening, everyone? Ultimately, user, observe very clearly. Okay, user is giving an input. Input is being provided to AI agent. AI agent takes it to where? Perception, where the understanding of the input is going to be taken care by the user, whatever is provided, and perception can process. The capability of the perception is to process the input only. Okay, and the input can be in any of the way, that it can be text, image, voice, whatever input you provide it. Then it goes to the cognitive layer. In the cognitive layer is where you'll see all your thinking and deciding is going to happen. And after that is been completed, then it will go to the action, where the action is going to be taken care based on the input whatever the user has been able to provide. Like we have taken an example of booking a meeting, that action will be taken up. After the action is been taken up, okay, then output whatever is being provided, it will be notified to user. Then only the user will be knowing that, okay, the agent has completed his job, and it is notifying to the user, so that user can then take the call accordingly, what based on whatever AI agent has been done. So that is the main idea here, everyone. That's the main idea we all have to understand. So this is one of the very interesting way, like how AI agents actually try to work upon. This is the internal architecture of the AI agent, everyone. So whenever you interact with any of the AI agent, it may be a single agent or it may be a multi agents. Okay, any type of an AI agent, when you go and try to interact with everybody, the point to be noted over there is you always have a user who takes the input, I mean, who provides the input to the AI agent. Then AI agent is going to take it and then process it in their perception layer, understands the question very clearly or the input. Then it takes to the cognitive layer where it thinks and decides, and then finally it takes the action. Once it takes the action, it will also provide the output to the end user. Okay, that hey, I have done this for you, whatever you asked, so please have a look into it and you can plan your day accordingly, or whatever you have been able to provide as an input. Same as like human beings only, everyone. So let's say you asked me a question, so what I have to do with all my intelligence, I have to first process whatever you are asking to me. After processing, then I will try to use my expertise, like whatever I have learned basically, or whatever I have done practically. I have to correlate that, and I have to think, I have to decide, and then finally I need to take an action to go ahead and answer that to you. And once I answer, I'll say that, hey, XYZ, okay, so this is the answer for whatever you have asked me. So I'll notify you. I'll mention your name and I'll say that, hey, this is what I'm answering it to you. Are you okay with it? Or you still further need any confirmation or clarity from my end? Simple example of how a human being behaves, nothing else. How a human being behave, if you take it, the same correlation is been happening over here. Only different things is the terminology. Only the terminologies are something which may be new to you. Otherwise, as a human being also, this is what we actually do. We understand, we process and then take a decision, and then we implement that action. And finally, we inform the output whatever we are coming up with. For that, there are three different names being provided here. One is perception, another one is a cognitive, and third one is action. That's it. So this is the clarity with which you all should be able to know that how internally the AI agent is going to work upon, with the three different layers being considered here, like one being your perception, second being your cognitive, and the third one being your action. So these are the core capabilities, everybody, with which we all should actually here be aware of. Okay, so hope that this makes sense to all of you. So this is one of the interesting and a very important concept with which we should actually be able to be aware about. Okay, so this is again one of the important thing which I just want to let you all know. So next, as we understood about perception, cognitive, action, and all these things, right? So now let me take you to the next interesting things which are part of, like, let's understand what is a single agent. Okay, as an agentic architecture we are learning right now, right? So yesterday we did not discuss in detail about what is a single agent, what is a multi-agent. We did not discuss in detail about those concepts. Okay, now I'm going to take some time out, give you that clarity between what is a single agent, what are the multi-agents, how they are going to be correlated. And one more good thing I'll say you, everyone. Today we will do the practical part when we enter into, right? We are going to take the examples of how a single agent works, how a multi-agent works in the healthcare domain. Okay. So that is the domain which we are going to target majorly for today. Like that, every day we'll target different sectors. In that way, you'll understand how to create those different AI agents. Okay, so let's do one thing here. I'll take you to the single agent in this scenario. Let's understand that how single agent plays an important role and what exactly is a single agent in this case. See, when I explain the single agent, right? First of all, what is a single agent architecture, everyone? See, single agent architecture means, like, let's say how we are trying to design this, I'll let you know. So here we are designing, like, let's say one smart agent, everyone. Okay, in this scenario, we are leveraging one smart agent. And this one smart agent only will be able to go ahead and do the work for all of us. So it is like it's going to act alone ultimately. Okay, it's going to act alone without any help from the other agents. First of all, you have only one agent. So obviously there are no other agents apart from only one agent. So they are all going to act alone, and then they try to fulfill whatever we want. Like as you see here, right? Like what are the some key points which have been mentioned over here? So they are going to work independently. I mean, it's like one agent will work alone. So it's like I would say it's like a robot, or it's like an AI assistant, okay, where it is trying to do the task everything on its own. I mean, there is no teamwork over here. It doesn't know what is a collaboration, and it doesn't try to do any teamwork. And that's not the fault of the uh, agent. That's not the fault of the AI agent, everyone, because the single agent architecture is such. The single agent architecture is such that where it is going to work everything on its own, that is in an independent manner. So it doesn't know what is a teamwork. It doesn't know what is a collaboration. Okay. And when do you use a single agent? You know, everyone, whenever you have any focused task. Okay, let's say whenever you have any focused task to implement, right? So to do that focused task, this single agent setup is going to be great. When you have a clear well defined job, like let's say only answering questions, like yesterday we have done, you remember, we asked a question like, can you explain the difference between AI agent and agentic AI, the demo part, the practical hands on. That is a single agent, right? You just ask the question, it will answer. You just ask question, it will answer. You can ask any question, it will try to answer. That's it. Okay. Or let's say book, you want to book a ticket. For that, why do you need a multi agent? You can use only one agent where it will focus on like booking a ticket for you, or maybe like let's say booking an appointment for you, or maybe let's say answering the questions to you. So it all depends. It all depends on what you're trying to work upon, and then it will try to target the task in a very focused manner, everyone. That's the very purpose of it, like where it is best for some focused tasks, like again where you can make sure that you're using it for the, let's say, a very clear and well defined tasks, everyone. For that purpose only this is going to be very much helpful. And then on top of that, okay, there is actually going to be like one main controller. Okay, there is going to be one main controller that will tell to the agent what to do and how to behave. Okay, so it will have only one main controller because you have only one agent. So it will have one main controller. That main controller only will say that how the agent has to work, like what it needs to do and how to behave is what will be mentioned over here. And it will not talk to other agents, everyone. There is no need to talk to other agents because you yourself are only one agent. To whom are you going to talk? Is it multi-agent? If it is a multi-agent, let's say you have more than one agent, then there is a purpose. Okay, there is a meaning also that you can interact with multi-agents. That makes sense. But imagine if you have, like, let's say only one agent, where is the scope for you to talk to other agents? So you no need to talk. Okay, you don't need to talk to other agents in the process here. Okay, since you have been able to work alone, so it doesn't need to communicate with other agents. This makes the things very quick and simple. See, when you are dependent on some other agents, sometimes it may be little slow because you're dependent on other agent, but here you are the only single agent and you are the only one who is going to work upon, so you don't need to depend on any other agents. In that way, what will happen, as you're not been dependent on any other agents, so automatically you're going to be very fast, and then you're going to be very simple in nature to go ahead and handle the things effectively. Okay, that's how it's going to work. Okay, that's how it's going to work, like where we need to understand, like let's say for an example, okay, let's take an example of a calculator, everyone. So calculator, what it does, calculator is like a best single agent, right? Let's say I want to do some operation like addition, multiplication, subtraction, or a division. What you will do, you'll simply take your numbers or the values, try to do that operation, and with that your job is completed, right? Your only job is what here, to do calculation. That calculation can be anything. It can be addition, it can be subtraction, it can be multiplication, it can be division, whatever you are trying to play around with. That is totally under your discretion, how you want to play around with. But the only purpose of using the calculator is to do the calculation. Okay, is to go ahead and do the calculation in a really well manner. That is what we ideally do it, right? That those are single agents. So basically, what I want to let you all know here is single agents are those agents which are like properly focused to do that particular task. Then use single agent and complete it off. You have only one task to do, everyone. You have only one task to do. Then why to create multi agents? Create a single agent, go ahead, complete that task. Let's say you want to book an appointment. That is the only purpose of your, like, then create a single agent. Let's say you only want to ask a question, read the answer. Ask the question, again read the answer. You only want to do this operation. Then you can also be able to go ahead and can leverage the single agent where you ask the question and can be able to read the answer whatever you want. That is how single agents are going to play a very important role, everyone. Where you go ahead and ask whatever you want and it will be able to go ahead and give you that assistance. Okay. So there is no multiple agents which are being allowed, especially in the single agent architecture, everyone. Okay. And if you observe the architecture here very clearly, okay. So if you see in this case, this is how it's going to work. Ultimately what it will try to do, again same as like what we discussed already at the start of the session today. So the user is going to ask, okay, the user is going to ask or give a particular input query, okay, and let's say the user will say, hey, tell me the weather, or let's say the user will say, book me a meeting. It can be anything, anything the user may go ahead and ask. Okay, now you know the AI agent is going to receive, the AI agent is going to receive and then try to process that information. Okay, the AI agent will take that query and it will start working to find an answer to take the relevant action. In that process, the AI agent will try to use its memory, right? The agent will check its memory or the knowledge base. It looks at previous chats. It looks at its data, whatever it has been able to learn with. It will look at the facts, and then it will try to help. It is going to understand what the user is actually looking for. Okay, and then it will also select if there are any tools. Okay, like any tools which can make this job easier. It will try to integrate those tools. Okay, like let's say the agent may pick up a tool to help, like example, if you need a calendar, let's say you want to book an appointment, so the tools will integrate with the calendar automatically, because when I need to book an appointment, I need to know what is your calendar, I need to know what's the time. So it will try to integrate with the appropriate tools. Okay, it's always going to integrate with the appropriate tools and check for the right type of the tool. So it will try to do all the internal processing with its memory, whatever it has already been able to learn and store with it. And then it will also try to integrate with the tools. Now, integration with tools is not mandatory, everyone. Okay, it is something like based on the requirement. Now, let's say if I want to go ahead and ask a question, and to that question I'm expecting the response. Now, for that, what tool I will integrate? That doesn't make sense, because they are integrating the tool doesn't make any significance. But at the same time, if I ask as a user to book an appointment, so there it can integrate with the calendar because it makes sense. So integration with the tools is not something like, as just because we are learning it doesn't mean that everywhere I have to integrate the tool. Wherever it is required as per the use case, you'll integrate the tool. Wherever you think that it is not required to integrate the tool, then there is no point in integrating the tool and taking it further everywhere. Okay. So that is the idea you all need to be aware about. Then what is going to happen? Then ultimately the agent will give back the output. The agent will send a reply, or it will try to perform the requested action, whatever the user was able to ask. And then the entire activity will be said to be completed. Okay. So there is a user. User is going to ask an input query. The AI agent will process that and it will take to the memory. This is a single agent architecture, everyone. This is a single agent architecture. Okay. The AI agent is going to consider it into its memory, where in the memory it will have all the data, knowledge base, previous chat, whatever the data with which it has been able to learn. If there are any facts, it will try to learn everything on its own. And then it will see if there is any possibility for integrating with any tools. Okay. Both of them are same only. Okay. So if there is a possibility, it will integrate. If there is no possibility, it will ignore. And then we'll come back with the output, everyone. It will come back with the output, whatever the user was asking, and it will give that relevant output to the user. This is how the single agent architecture is going to work like. Okay, this is the way how the single agent architecture is actually being outlined at the end of the day. Okay, so this is the clarity which I just want to make it very clear to all of you, which every one of you should be here aware about. Okay, now what are the examples? What are the examples of a single agent, everyone? So today in the market, if you go ahead and see what are the different examples for the single agent here is, if you see, these are already some of the examples which are already been available in the market. Let's say a simple chatbot. Yesterday, whatever we did is like a chatbot only, a very simple, very, very basic one. Let's say in the chatbot, what people do, In the chatbot, people go ahead and try to ask some question, and the chatbot will go ahead and reply to your question in the form of a message. That's what your simple chatbots are going to do, right? So it will work alone. It's going to work alone. It will understand your message, and then it will reply based on whatever you are going to ask. So that's a single agent. Okay. And then you have the recommendation system, everyone. This is also single agent only, like where it will suggest the content based on your past behavior. Let's say what it will try to do, as you know, single agent is having a memory present with it. Correct? So it will try to store in its memory. For an example, if Prashant likes to watch a thriller movies, okay, now my single agent will observe my patterns, where it will try to understand that if I like thriller, it will always go ahead and it will store it in its memory that I'm always continuously watching thriller. So it will always suggest me the content based on my past behavior, and it will try to identify and it will always try to recommend me what type of movies I like. In that particular genre only, it will try to target and give me the movies. In the same manner, let's say it may be related to movies, or let's say you like to read a lot of books, it will try to recommend the books to you. If you like a particular product, it will always try to recommend you to that particular product, because it knows that in its memory it can be able to go ahead and store a lot of different things which are actually aware about. Okay, that is how in the recommendation system also you can see the single agent can work specifically, and you can use it for your automated data entry. Like let's say here the agent will take the input, it will fill the forms for all of you. Whatever the forms you want, it can be able to fill it in an automated manner, all on its own actually. So this is basically if you have any repetitive tasks. Okay, if you have any repetitive tasks, right? So you will see that, I mean, like as an automated data entry, we can take those repetitive tasks into consideration, and then you can fill the data without any constraints or difficulties. Like as an automated data entry, what are we going to do is we'll try to read all the data and fill the data appropriately. So for any repetitive tasks, also single agent can be very much helpful for us. Okay. Now, basic smart home control. For this also, you can use the single agent. Okay. So basic smart home control is nothing but, let's say, uh, I will say to my AI agent, hey, turn on the light. Okay. Turn on the light every day, let's say at 5:30 p.m. Okay. So what it will do, this agent will always try to do this activity whenever the time is 5:30 p.m. Okay, as a smart device, it will go ahead and then try to does everything on its own. So I gave some instruction where it is going to focus only on that instruction. So single agents are meant for what purpose, everyone? Single agents are meant to do a focused action. You give focused one particular action, it will be able to go ahead and do that for you. But if you need multi-action, then you will require multi-agent. But if you have a focused action, like, hey, this is what you have to work for me, then it will be able to do the task in a really well manner. But if you give multiple actions and then you ask the single agent to do, then it may not succeed in a way like how you give one single task to complete it. Okay, so single agents are really great in doing one task at a time, that too in a very accurate manner. So these are some of the examples where you see that one at a time it takes and then tries to complete them and gives you the relevant output which makes sense at the end of the day. Okay, that is how your single agent architecture plays a very, very important role, everyone. And that's the significance of having the single agent architecture in a better manner, like where you give one task and it does a great job to all of us to identify the things. Okay, now in the same way, as you understood like all some good things about the single agent, but what drawbacks or what limitations does it have, which we should be a little bit aware about? So the first thing is, everyone, you know, any architecture which comes into the market, it will definitely have some pros and cons. It's not like an architecture will always have pros. It will also have some disadvantages or some limitations, which we should be aware, so that we use when we use these agents, at least we need to be a little bit cautious in those approaches. Okay. So first thing is, if you see, uh, the flexibility is very limited, everyone. Okay, so whatever the flexibility you want, that flexibility is basically limited in nature over here. Like, for an example, here the single agents are designed for what? It is designed for one task, okay, or a simple task. You have either one task or a simple task to make sure that you leverage your single agent architecture. Now, whenever, let's say, there is a dynamic situation, okay, whenever there is a dynamic situation, that means where you have to adapt, okay, where you have to adapt to new, or where you have to adapt to some changing situations, then the single agent architecture may not play an important role everyone. Like, let's say we created a weather bot. Now the weather bot, that only, I mean, the weather bot will only go ahead and give today's forecast, but it cannot suddenly handle any updates which comes to it. Let's say today it gave you that the weather is around let's say 30 degrees Celsius. Okay. Later, because of unforeseen situation, let's say the temperature went down suddenly to some, let's say 20 degrees Celsius. Now what will happen is it cannot immediately cope up that part. Okay, it cannot immediately understand, because it learned that today the temperature is going to be in a pattern called as 30 degrees Celsius. Now due to some external disturbances, or the climatic condition has changed all of a sudden after, like within first half of the day, then your single agent will say that, hey boss, I cannot handle this situation, I'm not so flexible, I already fixed that my temperature is going to be 30 degrees Celsius for today. Now, it will not be very immediate. It will say you that the temperature has fallen down to 20 degrees Celsius, but it's not going to be immediate to let you know that part. So it's not very flexible. That's what, as I said, right? It has a specific goal or a task. So it will try to complete that, but immediately, like again, making it going back to a dynamic situation, or making it to go back to the existing situation becomes a little bit very difficult here, everyone. Okay, so make like it struggles to go back and then try to move to the changing situations. That is little difficult in the single agent architecture, everybody. Next, you cannot you cannot be able to scale it for some big tasks. Let's say you have a big task to work upon. Now for big tasks, the single agent may not be the best option. So if the job becomes, let's say, very big or more complex, so ultimately the single agent in this scenario will not play a very important role, everybody. Okay, that's one of the significance we need to be here aware about. So as the tasks becomes bigger, okay, when we go ahead and then try to ensure that if it's going to be like a very huge thing or very complex patterns, then your single agent will just give away there. Okay, like as I said, right, like where you need a lot of rework, okay, or maybe you need to handle a very complex scenario. Like what can be the scenario? Let's say you made a chatbot. Okay, you made a chatbot which is being made for all, let's say, FAQs, like a frequently asked questions. So then what will happen? Like, see, it's a very big document. You have to go through it, and then you need to answer the question based on whatever the end user is expecting. Okay. So now what will happen? Let's say if you gave a FAQ document, let's say you gave a FAQ document and you say that in this FAQ, there are a set of questions, the frequently asked questions. Now, when the user is asking a question, right? Like when the user is actually asking the question to you, then it will be able to go ahead and answer that for you. Now, let's say the user is asking a question which is not there in the frequently asked questions, FAQ. It's some other random question the user is asking. It will give up. It will give up because its task is what? The single agent task is to ensure that it will go ahead and answer whatever is there in the frequently asked questions, FAQ document. Now, as long as it is there in the document, well and good. But if it is not there in the document, then it is you are deviating from the task what is being provided to the single agent. So then it will give up. It will just simply say that, hey, I'm not sure like whatever you're trying to intend to ask, and it is just gonna not answer anything, or either it will hallucinate and try to give some random answers associated with it, everybody. Okay, so that's the idea. I just want to know, I just want to let you all know that big tasks, handling big tasks is not a, it's not a very flexible thing for the single agent architecture, everyone. Okay, and then on top of that, okay, as you're using what agent here? Single agent. Now, when you are using a single agent here, everybody, you need to understand in this scenario, one agent, okay, one agent will have a very limited brain power because you have only single agent, right? So single agent will have limited memory, okay, and limited processing and limited processing power. Okay, so what will happen if you really want to do something very fast, if you really want to do something smart, okay, what will happen is the single agent will actually follow this approach. It will try to really do fast, it will try to really do smart, okay, there is no doubt in that. But what is going to happen is, like, one agent, as you have only one agent, right, it will be limited, you know, right? Like as a team, when you work, how the efficiency will be there, everyone, it will be very high when you work as a unit or when you work as a team. Imagine when you work as an individual. So the efficiency will also be great when you work individual, but when you compare it with the team, so obviously your efficiency will always be low. So that is what I try to say here. You will be fast, you'll be smart as a single agent, but when you compare it with your multi agents, you're not gonna be that fast or that smart when you refer to the multi agent architecture, everyone. Okay, so that's the thing, like to make it very simple to all of you, just to correlate or just to try to understand in a better manner, let's say, what I can say, okay, let's say like there is a delivery guy. Okay, there is a delivery guy who is a single person. Okay, there is a single delivery person. Now let's say that single delivery person, if we give that delivery person to go ahead and give the package to the nearby location, but if there are, let's say, 100 packages, and all of them are long distance routes, they will struggle. Like, let's say, I gave 100 packages to that single delivery guy, and I'm saying that, hey, you need to traverse across like 50 kilometers radius, and then you need to give all these parcels within a day. Now, that's a very struggling factor, right? How would I traverse across 50 kilometers and then try to give this 100 parcels within a day? It's very difficult. But in the same scenario, if I would say that your radius is only 5 to 10 kilometers only, and where I'm giving you 100 parcels today, where you go ahead and complete it, or 50. So there, what did you do? There you made it more focused. You just did not give some random thing. Instead, you made it more focused, saying that your radius is 5 to 10 kilometers. These are 50 parcels or 100 parcels I'm giving to you. Please go ahead and do the delivery. That becomes very easy. That becomes very easy because the radius is very limited. And yet then what you can do is, like, you can go ahead and can complete it off. It's like that. Single agents are more like that, like where you are being given a focused task and you'll work on that. Now, let's say you are giving one task which is totally relevant and another task like which is totally irrelevant, then it will get confused and then it will say that I cannot handle this. Okay, because I am only meant for working on focus task. If you give me that focus task, I'll go ahead and work and will help you out in whatever way it can be. That's what the single agent ideally tries to say to all of us. Okay, so that is the understanding. Just these limitations are not very big limitations, I would say, everybody. Okay, these limitations are just to let you know that as a single agent, I am meant to do a focused task. I'll only do that. And if you give me multiple tasks in this scenario, then that's going to create a problem to me because I am meant only to do one particular task, which is very focused for me. If you give me multiple things to do, then I will lose the essence of what I need to focus on the main part, right? I will lose the essence, and that's going to create a difficulty for me, is what your single agent architecture would actually try to say. Okay, so yeah, that's the overall idea. I just want to make it very clear to all of you. I'll complete off the multi-agent architecture also, everyone. Then I will take up all the questions about the single agent, multi-agent, and the AI agent architecture, whatever we have covered. In that way, I can take up a lot of questions, and you will also see some broader perspective in understanding the topic, and then you can make me ask like any of the different questions, or maybe I can go ahead and try to answer relevant questions related to it. Okay, and then coming to multi-agent. So multi-agent also, as you know, it's more or less like gonna be little bit different over here. If you see, same thing, nothing changes. Only thing is you're gonna have multiple agents to collaborate. That's it. So here you see, there will be like multiple AI agents. Okay, all of them are going to work together, everyone. So each agent, Okay, each agent is going to handle a part of the task. Like again, so as you have multi agents, so all these agents, they will work collaboratively like a teamwork, where they all will try to share the information among themselves whatever they want, and then they will also try to collaborate. Okay, they also try to collaborate to make sure that they finish any job whatever is required. So if you have any job, so they will try to collaborate and they will try to finish them appropriately. So as a multi-agent architecture, I would say all these multi-agents are going to work together, everyone. So let's say you have agent 1, agent 2, and then agent 3. All these three different agents are going to share the information, and then they are going to collaborate together so as to make sure that they can complete whatever the job which is being provided to it. Like let's say one agent takes the responsibility to talk to users. Okay, let's say one agent talks to users, and you can say like another agent will look into the data, okay, which is being present, and then let's say the third agent will go ahead and will make the decision. So something like this. Okay. All three of them at the end of the day will work collaboratively. One agent will do one task, second agent will do second task, third agent will do the third task. Imagine you're working in a team in an organization. So the very purpose of the team is what you all can distribute your work, right? Like first team member may be doing a particular task, second team member may do another task, third team member may do like a third task. All three of you will combine your work, and finally that is the output. The same approach is also going to work over here when you have multiple AI agents who are going to work together, right? So each agent will take a particular task, they will share that information, and all three of them will collaborate to each other in order to complete a particular job, whatever is being provided. That is how these multi-agents are basically going to work for. And these are really good for the dynamic environment, everyone. Like which was been lacking in the single agent architecture, right? In the multi-agent, you have the dynamic approach to take it further. Okay. So basically, what is going to happen over here is, if you see very clearly, let's say if you really want to use it for enterprises, because in the large scale companies or in enterprises, right, your requirements or the way you want to use is not rigid. You have to be very flexible. If you are not flexible, then things will not be done easily. So for that, you need a dynamic nature. So for dynamic nature, like especially in all the enterprises, you'll have a dynamic way of working, everyone. Okay. So where things change very quickly, I mean, where everything is going to be very, you have to be adaptable and make sure that whatever things are getting changed, you should like go ahead and fulfill that particular scenario, everyone. So agents can be placed, okay, whatever agents are there, they can be placed across different locations, and then they can work together. So if there is any changing requirement also, it can adapt to it and can give you all the relevant results, whatever is required. So it also works in a very dynamic environment. And here, every agent, they are not going to repeat the same task. Every agent will actually have a specific role associated to them, everyone. Okay, every agent which is present, they will have a specific role which is being granted to them, and they are going to fulfill that particular role. Okay, so each one of them, they are going to have their own responsibilities, like what they need to work upon. Okay, so they will I mean, they try to divide the work, and then they will try to finish the things in a very faster manner. Okay, like responsibilities, right? Like in a team, you may have a let's say the one who is going to be good in designing the work. There may be one person who is good in developing the work. There may be one person who is going to be good in managing the work. Like that, every role, how we have the different responsibilities. In the same way, every agent will have a specific responsibility and the task which they can be able to work upon. Okay, in that way, you can handle the things more proactively. And then if you really want to make the multi-agent concept successful, if you really want to take this to the next level, and if you really want to make it successful, right, you have to understand one thing. Agents need that coordination and communication. As long as these two things are there, all your multi-agents are going to I mean, they are going to make everything successful based on whatever you want. But if that coordination and communication is not there, then everything is literally going to be failed. Same as like how we learn about the team collaboration, teamwork. It's the same thing. As a team, when you all work collaboratively, when you coordinate and when you communicate, you give an effective output at the end of the day, right? That is how it works. But let's say if you are not coordinating, you're working isolated or independent, you don't want to collaborate, you don't want to communicate with others, then what will happen? As a team, you are going to literally fail. As an individual, you may do great, but as a team, we will fail. So that is the reason, if you really want to make your multi-agent architecture to run successful, all the agents which have been present here should be able to coordinate and communicate themselves, so that we can always be able to come up with the right output at the end of the day, everyone. Okay, so that's the most important thing which we all should here be aware about. Okay, so that's the overall idea which I just want to make it very clear to all of you. When we talk about the multi agents, these are some core topics which we all here should be aware about. Okay, and then like just to see the architecture, like what we have already discussed, right, as part of the single agent architecture. In the same way, let's also try to look into the multi agent architecture which is being present. Okay, this is the architecture you see. Same again, you are going to have a user. Now user is going to provide an input, right? The user is going to ask a question, or the user may go ahead and request a particular task for all of us. Okay, so it can be anything. The user may ask anything as an input. Now the query will go to your main AI agent. Okay, the query or the input, whatever you are asking, right, this will go to your main AI agent. So the main agent uses its own memory again. The main agent will use its own memory, and it will also try to use its own tools. Okay, so now what will happen? Memory is where it will check all the past interactions, or if whatever it has been trained with. And if it needs any tools, it will try to integrate. If it doesn't need a tool, then it will ignore it. It all depends on the use case. Okay, now if the task is big, if the task is very big, or if it needs like some multiple steps to be done, then the main agent will delegate. The main agent will delegate the part of the work to other AI agents which are present. So basically, every AI agent is going to have its own memory and the tools. Now, if this AI agent, the main AI agent, believes that it is a very big task and we need where multiple steps are required, then ultimately the AI agent is going to delegate that work to the sub AI agents which are present. Okay, so let's say this AI agent is really good in summarizing the documents. Let's say the specialty of this AI agent is to summarize the document. So this agent will take that work, will try to use its all memory and then tools, and then it will try to summarize the document for you. And then there is another AI agent. The another AI agent is really good in, let's say, writing. Okay, really good in writing and sending the email. So it has that capability. So then this AI agent will use its all its memory, and it will try to write and then send the email. Okay, so basically each sub AI agents, again, they are going to have its own memory and tools where they will try to learn from it, and they will be able to take it up further. Now these sub agents which are there, whatever the task which they have been specialized in, they'll try to complete that task. Okay, they will try to complete it off, and then they will send the result back again to the main AI agent. Okay, and then after collecting all the results from these sub AI agents, the main agent will try to find the answer, final answer, whatever is required, and will be giving back to the user as an output. That's it. This is how the system is going to work in the multi-agent architecture, everyone. Okay, this is how it's going to work. Like imagine basically what do we call, like in a team, right? When you work in an organization in a team, you'll have a team lead. It's more like that. The AI agent here is going to act like a team lead here. Okay, where the team lead is going to delegate the work to team members, right? Like, hey, you have to do this, you have to do that. And how the team lead will delegate the work based on the specialization, whatever you have. Let's say you have been good in design. There's a design work. So obviously I have to give it to you because you have a specialization in design. Let's say you are an architect. That means your specialization is to do like architectures and find out the different approaches, designs and all. So I'll be able to give it to you. Let's say you are a developer. Then I'll give you the development work to implement it. Same is what is happening here. You have the main AI agent. The main AI agent will first analyze whatever the request coming from the user using its own memory and then the tools. After it understands everything, then it knows that, okay, let me delegate the work to sub AI agents. Okay, now let's say what this AI agent is good in summarizing, then let's give the summarizing aspect to this AI agent. Let's say there's another AI agent who's really good in writing and sending the email. Let me then delegate this work to this AI agent where it can write and send the emails to me. Okay, in that way, all these AI agents will again use their memory. They'll try to complete their job. After completing their work, they will inform to the main AI agent that, hey, whatever the task we have delegated to us, it's now completed. So now the main AI agent, what it will try to do here, everyone. So the main AI agent will try to collate and collect all your results, which I have been able to provide. And then as a main AI agent, it will try to send the final answer as an output to the user. Okay, as an action, it will be able to send it back to the user. That's it. So that's how the system is going to work, everyone. User will be able to send the input to the main AI agent. Main AI agent will delegate that to the sub AI agents, and the sub AI agents will use it, all its memory and then the tools. If it is required, it will try to integrate the tools. If not, it will try to use its memory. It will get back the results, and then it will delegate again back to the main AI agent. The main AI agent will send it back to the user as an output action. Okay, so this is how your entire multi-agent architecture is basically going to work upon, everyone. Okay, so that is the idea which I just want to make it very clear to all of you so that you get a broader picture of how things actually work. So now with this, we are done with the single agent architecture. We are done with the multi-agent architecture. Okay, we are also done with, let's say, what is a perception, what is cognitive, okay, and then what is an action. We completed everything. So now what am I going to do is, based on whatever topics we have started from the start of the session to till now, whatever I have explained to you, I'll take up all the questions, I'll try to answer them, and then we will proceed further right now to the hands-on activity, okay, where we will also do some practical part. Right now, whatever theoretical architecture which is required for all of us, we got that clarity, everyone. Okay, so now the only pending thing is, if you also do some practical implementation of it, it will give you a broader exposure towards what we learned, and you can correlate it practically so that your concept will become very much soundproof. Okay, that's the main idea. But before we enter and do all these type of things, let me go ahead and try to answer all your queries, and then we'll be able to move ahead. So give me 1 minute. Let me try to take up the questions. The people who are not able to hear me, I would request you to please rejoin back, because it's not something which everybody has reported. So just make sure that you can join back if you are facing any connectivity issues. Okay. Yeah, security part we will have security aspects we'll discuss once we enter into that module altogether. Okay. So right now, whatever we are learning is only about the architecture. We have an entire module on understanding how ethics play an important role. What are the compliance policies? How you have to use the AI in a responsible manner. All these questions are being there, which we will discuss once we enter into that module. Okay, so there we will discuss definitely about how security is going to play a very important role at the end of the day. Okay. Yeah, multi-agent, you can classify that as an agentic AI server. Okay, single agent will not be an agentic AI, but most of the multi-agents are considered to be an agentic AI at the end of the day. Okay. Basically, see, RAG can also be considered as a multi-agentic only, Trisha. RAG pipeline can also be considered as the multi-agentic part. Okay, they are not different actually. How multiple agents communicate with each other, that I will explain to you right now when we will do the hands-on activity, right? You'll understand that. So your LLMs in between will try to communicate and will make sure that all your agents are connected to each other. Okay, that's what is going to happen. So now let's go one by one in the chat. Yeah, over to you, Mukesh.
Hi, I have one question here. So just assume I'm going to create one AI agent for particular client. Okay. So to get that memory, so where the data will store, or like
Vector database.
repetitive,
Definitely you
yeah,
remember.
where like all the or repeated data, something. So
Yes.
the memory part, so this is going to store in LLM, yeah, in client database. So what will happen?
See, it depends, Mukesh. Like there are two configurations here. Okay. Answer to be first. I'll give you an answer. Answer is in one line. It is LLM. LLM will handle all your memory processing and everything. Now, there may be a request from, let's say you are my client. You'll say that, hey, I don't want to use LLM because LLM is someone else network, right? They have developed it. Now, can you go ahead and create me a space where I can store my memory instead of storing it in LLM, so that we can use LLM as one of the API and use that use its intelligence, but let's not try to dump the data onto it. Then I will say let's have our own vector database. Within the vector database also we can store the memory. It's up to us like how you want to integrate it with. Ideally, in out of 10 instances of the AI agents, what you see, 8 instances are like where LLMs only handle the memory. If you want to customize and fine tune the things like where you want to have your own vector database, there also you can be able to store your memory and you can save it. But ideally, the answer is LLM only handles all this memory and everything, Mukesh.
Okay. So for a private agent, like that is for particular client, so we should not use common LLM because it will
Exactly.
breach the privacy. So we have to store in
Correct.
vector database, right?
100% right, Mukesh. Yeah, exactly. You can create your own private network and have your own vector database. If you don't want to give away any of your data, or if you're thinking that your data will go away to some other entity who is owning that LLM, right? Then, for as you rightly said, for private part, you can just be able to go ahead and leverage it as a vector database where you can store and have all your memory. Okay.
Okay. Hope this type of case scenario we will do in our program.
Discuss that in RAG. Okay.
Okay.
Retrieval augmented generation is something like where we will have our understanding of vector database, how to integrate it and all. We are still in day two, but we'll talk about those things. Not a problem. Okay.
All right. Thank you.
Thank you. Over to you, Shilpik. If you're talking, I'm not able to hear you because I see that you are unmute, but I'm not able to hear you.
Can you hear me now, Prashant?
Yep, perfect. I can hear you now.
Yeah. So my question is, in technical terms, what exactly is an AI agent? That is my question one. And my question two is, in yesterday's session, in the coding example, it was regarding question and answer using LLM. So how is that different than generative AI? Because in my understanding, generative AI also is has a similar framework. So these are the two questions I have.
Okay. AI agent technically is nothing but to do a particular task or an activity for us. Let's say, for an instance, first of all, I want to make it very clear to all of you, the generative AI, agentic AI, AI agent, they are all same. They are not different. I mean, you will not find, that is the reason you cannot be able to broadly classify what these three all are. Okay, because if you let's say you take a world of artificial intelligence, within that you have machine learning, deep learning, you have your generative AI, and today we are talking about AI agents and all of those things. They're all same. They're not only one small line which cuts off them. Okay, like for an example, what you do in generative AI, everyone, in generative AI, you can actually, it's a jack of all trades, right? Like Chat GPT, Gemini, and all of these things. What you do, you go and ask any question, it will try to answer that to you. Yesterday, that's what we have done. See, now you can integrate, let's say you are creating your own chatbot, Shilpik, for an example. Now when you're creating your own chatbot, right, what will happen there? Now whenever you're creating your own chatbot, in this case, like you can integrate that application, like whatever the code we have written yesterday, you can integrate that with your chatbot. Now your chatbot will try to interact with your LLM and will try to give an answer. Like how it is going to work, like now you are asking the end user, you don't need to go and integrate with Google Gemini, or you don't need to ask anything in those LLMs. Now I created a chatbot for you. Now you can go and ask any question, okay, but you can get the response. But what did you do? You have actually created a chatbot in your application which is fine tuned to your model. So whatever question which the people are going to ask, they'll be able to answer that to you. So yesterday, whatever the application which we learned, it is more or less like a generative AI only. So yesterday somebody has asked me that question also. So even in Gemini also, I can go ahead and write the prompt and see the response, right? So same, I agree. Even that also you can do instead of writing the Python code, integrating it with the Gemini API key and then trying to do. But today, when we do the hands-on activity, right, Shilpik, you'll understand the significance of an AI agent. So what is the difference is LLMs will only give you the text content, whatever you want. AI agents will actually fine tune and give the requirement as per what you want. So now you are using that LLM as per your customized manner. Now, let's say I want to take a doctor appointment. Then I want to provide my symptoms. What is the problem I'm facing? So it will now act like your own agent. Like it is going to work only for you. Okay, now ChatGPT is going to work for everybody. In that, you are the one person, like where you're asking your request. But here, the AI agent is going to work in such a way that you go ahead and give any of your problem or concern, it will be able to assist you in all the different ways in which the LLMs cannot be able to do that for you. So we are creating a fine-tuned model where things become much easier, Shilpit. That's the major aspect. Now, today when we do hands-on activity, you will get a much broader picture that how these agents can be customized and we can use it for our own purpose instead of being dependent on the global LLMs which are available in the market. That's the major idea behind it. And it does the action for us, Shilpit. LLMs doesn't do an action. You ask LLM to go ahead and book a ticket, it will not do. It will only be able to say
Correct.
that what is that you need to do, but AI agents can do that for us. That's the biggest difference between both of them. And that you will learn when we move forward, right? When we move forward with the day by day, all the topics when we cover, you yourself will ultimately understand that how this AI agents will have a significance when compared to others. Okay?
Okay. Okay, Prashant. Yeah, I will wait. I guess for a couple of sessions. I guess then things will
Absolutely,
be more
absolutely.
clear.
Today is just day two, right? So we have some
Right.
interesting things as we move forward. Gradually, you will also be able to get to know different things which the agent can do for us. Okay. But for the time being, this is the example I want to let you.
Okay.
Is that fine, Shilpit?
All right. Yeah,
Thank
Prashant. Yeah.
you.
Thank you.
Thank you. Over to you, Manish.
Yeah, actually, I want to understand the prompt plus LLM is like agent because we are also learning.
Prompt plus LLM is one of the component in your agent. That's not the only thing. Okay. Prompt plus LLM. See, prompt plus LLM is, say, for an example, good one you have asked. Okay. Let's say, for an example, Manish, we are human beings, right? Now, we have our human brain with us, which is our intelligence. Now, for an example, somebody comes and if they don't say me that, hey, you have to do this, then I cannot think, right? Maybe I have a lot of intelligence, but if somebody comes and says me that, hey, please go ahead and do this activity, then I will use all my intelligence and I will do. Same thing, prompt plus LLM in your agentic world says that prompt is an instruction or the question which the user is asking, and then LLM is its intelligence. That's the brain. So using both of them, it will try to fulfill the criteria, whatever the end user is expecting. That's it. That's the major idea behind it. Okay. Hope that answers your question. Perfect. Thank you. Over to you, Trisha. Trisha, I'm not able to hear you if you're talking. Okay. Let me move on to the next. Bhaskaran.
Yeah, this is regarding the multi-agent architecture. Just I wanted
Mm-hmm.
to clarify a few points because the
Sure.
architecture that you have shared is to me like more like a hierarchical architecture where the
Mm.
agent, like the primary agent, will what do you call, will communicate with
Mm.
other agents, right?
Mm. Mm. Mm.
Yeah, because my understanding is based on the pipelines, right? A pipeline
Mm.
pattern where you have
Mm.
other than the hierarchical, we have something called a parallel or a decentralized architecture or a
Mm. Mm.
graph-based architecture, right?
Mm.
So
Mm.
specifically based on your terms, I see it is more of a hierarchical architecture, right? But
Mm.
I
Mm.
think is it possible? It is possible to implement parallel graph-based or
Mm.
even decentralized architecture, right?
We can do, but the AI agents, most of the times in that perspective, they hallucinate. Ideally, what happens is when we do right now, after this, right, we'll be going to a practical part, the hands-on activity. There you will understand that how it can do parallel processing. Okay, just for your understanding, what I did is I made it a hierarchical approach so that everybody who is not from the non-technical background also they can understand. But ideally what happens is the AI agents also we can parallelly do processing, but not most of them we have to do parallel processing because it sometimes get hallucinated. So yeah, it can still further work upon where we will do hands-on activity. Right there, I will explain to you that how well it can be able to handle the even the parallel processing also. Okay, so we'll consider even that part. But just this is for to make everybody understand as a hierarchical architecture so that everyone can understand it in a clear manner with regards to it. Okay, perfect. Thank you. Over to you, Harshvardhan. Okay, I think Harshvardhan, you're there.
Yeah, sorry. Yeah. See, I've got two questions. First question is regarding this architecture which you have shown regarding the single agent and the multi agent. This also applicable to the agentic AI, right? I mean, because all are similar.
This is agentic AI. Yeah.
Okay. Second
Don't get
question: Where is
confused. It's simple. Just one thing to say to and to others also, as you raised this point, they don't get confused. Agentic AI, AI agent, what these are. See, all are same only everyone. Okay, AI agent is meant for only one task, single agent. Agentic AI is nothing but complex patterns it will try to identify and will do, for which you need multiple AI agents required for it. That is it. This is the only thing. But at the end of the day, all of them are AI agents only. Okay, move on, Harsh.
got it? I mean, so basically, agentic AI. This architecture is also valid for agentic AI, and everything is quite
Exactly,
similar.
exactly.
Thank you.
It's all same.
Now,
Hmm?
uh, sure, thank you. And now in this architecture, where is the LLM based out? I mean, where will be the LLM? Because we mentioned we saw the memory, we saw the tools.
Memory,
If
memory, memory, memory.
okay, it will be.
In the memory it will come. LLM will have its own intelligence and everything will integrate it with the memory over there. That is where LLM will come into the picture. Okay.
Okay, got it. And the last question is this: you mentioned about the team lead architecture, right? One will be team lead, and he's going to assign the task to other agents.
Just an
It will
analogy. It's not every time the
okay.
same, Harshvardhan. It's just an
Okay, yeah,
analogy to make you
that's what I was
understand.
asking.
Mm.
Yeah, is it also possible that all three agents work together? Maybe
Exactly,
different.
exactly. That's what. Haha. They all can work together. That's what one of the participants before you has asked, right? It's not like
Okay,
hierarchical. Instead, we can also
okay.
do parallelly work. Parallelly means everybody
Parallel
should be
processing.
accountable, right? That's what. Just for the understanding, I said like that. Otherwise, it's not every time that the team lead should be there, a main agent should delegate to others. It's not like that. Parallelly also they can process.
Okay, fine. Thank you,
Got it,
thank you, thank
Harshvardhan?
you.
Thank you.
Yeah, thank
Over
you.
to you, Debashish.
Hi, Prashant. Good morning. Can you hear me?
Yes, yes, I can hear you.
Yeah. So, Prashant, I have questions on memory and cognitive, what you already explained.
Mm.
So, what I understood, like you told, like memory is kind of better DB where I'm storing my data, right? Which is like private for me or for my organization, and my AI agent will get the context from that database. But what is my question is like if you see in the chat GPT, if I keep on asking, right? So in the prompt I have asked something,
Mm.
and
Mm.
it is still memorizing my previous chat also, and it is trying
Correct,
to get the context from that previous chat. So
correct.
how this deciding factor will happen, whether to go to the database or try to check from my old conversation.
Your LLM internally has two components, Devashish. Okay. One is your LLM is trained with a huge amount of data. Correct. So it has its own database. Okay. That's a vector database. Okay. Where everything with whatever it has been trained with, it is going to have all that information. That is one approach. Then in all these LLMs, right, you have an architecture called as a transformer architecture. We use transformer architecture to make sure that transformers are very advanced in nature. Okay. So what transformers will do, transformers also will try to understand the context, whatever you are asking. It will try to understand who you are, what is your name. Somewhere if you have used your name, it will try to understand that it is your name. So everything is in the vector DB only. In the vector DB, it will try to segregate it into different parts, Debashish. So it will say, okay, this is the training data with me. Okay, if you have a vector DB like this, your vector DB will be segregated in this way. Okay, okay, this is my segregation. One is my training data in the vector data, I mean vector database, like where I've been trained with. Next is my context data, where I'll understand the context of whatever you're asking. Next is personal data. Personal data means, please don't think it's your phone number or address or anything. Personal data means it will try to understand you personally, what is your context. So then your LLMs are so much intelligent enough that they know like what at what point of time, what data they need to fetch, where they have to go, and where they need to pull the data and give it to you accordingly. That is the segregation with which it is going to come up with. Like basically in your brain, okay, or in your intelligence, you have a lot of data. Now what will happen based on the what the user is asking, you'll try to give the information to them, right? Let's say for an example, I can go ahead and answer, but I know it is Devashish who's asking the answer because I could see that. So I'll put your name, I'll put a name, and then I'll say that it is you who are asking because I could remember that you are the one who has asked me. So I'll remember that, I'll put your name there, which is nothing but it understands that, okay, this is Prashant or this is Devashish. It will try to understand that and then it will try to put up the relevant answer to you. So it has that segregation where it will try to identify and give you the result at the end of the day, Devashish. Is it clear to you? That's the segregation which happens internally.
Yeah, thanks, Prasad. And the second question is this multi-agent configuration.
Mm.
So
Mm.
the parent agent, for example, the primary one. So it will also do the LLM query, right? When I ask the questions, so
At
it
the
will
end
do
of
the
the day,
LLM.
everything is LLM only, Debashish. To make
Okay,
it very
okay.
simple,
So it get the
it will not have
yeah.
intelligence otherwise. Yeah.
So once it get the context, for example, I asked something, it got the context, and now this the primary AI agent need to check which agent it should have to connect, right, to get the correct
No, no,
answer.
no, no. It will not it will not go ahead and see which agent it has to classify. Agent is something which you are going to create it. You have to have that understanding whether you need a single agent or a multi-agent. That will not decide. LLMs or any analysis, whatever you have seen right now, they are not analyzing which architecture to use it. They are saying as an AI agent, I have single architecture, multi-architecture, multi-agent architecture. You decide which one you want to use it. It just says that. Okay, now among that list of architectures, you need to choose which one works best, and it will give you the intelligence to find out the query, whatever you're asking as an input. It will try to process and give you the output out of it. That is it. It will not decide which architecture you have to use. Then in that case, what you need to do is you give a scenario. You give a scenario to your LLM. ChatGPT or Gemini. Say that, hey, this is my requirement, this is my case study. Now you say me whether I need to go with a single agent or a multi-agent. It will give you the thought process behind it. And then you can adopt and implement either a single or a multiple agent, Debashish. That's how it should work.
Yeah, that is not my question. My question is like, if I get the context right from the first query and the primary agent. Now, how primary agent will pick like which agent to communicate? So the
That's what I
primary
said,
agent will.
right? No, no. So we don't have primary or secondary agent like that. All of them are same only. Okay, let's say there are three agents. Now, for an example, think logically. There are three agents. First agent is to read the document. Second agent is to summarize the document. Third agent is sending the email. Now, you say me logically, how will you take it up, Devashish? If there are three agents, which will go first? First one is reading the document, right? Second one is it should summarize. Third one is it should send the email. Now, for an example, if I put the third one first here, like first summary, taking the, I mean, right, sending the email without reading the document, without summarizing it, will it make sense? No, right? So AI agent will internally identify the logic based on whatever agents you have been able to create. It will internally identify which one has to go first, which one has to go second, which one has to go third, or else we can align that appropriately. Now, when after the break, once we do the AI agent, right, multi AI agent will get an understanding automatically there, where I will set up multiple agents, then you will only understand that this is how the sequence or the logic with which it has to go with. Then accordingly, it will follow that particular sequence, Devashish.
Set of primary agent. Okay, it will not go to always the primary, right?
Correct. It's
Okay.
logical always. It's always logical. Logically, which makes sense, will go to that. Okay,
Now it's clear. Yeah. Thanks.
perfect. Thank you. Yeah, over to you, Neeraj, quickly, so that we can go for a break and come back, and then we'll go with the next set of hands-on activity. Yeah, over to you, Neeraj.
Yeah, hi Prashant. Uh, I just want to understand that how the LLM is different from SLM in context of multi-agent and single agent. Is it like SLM is we are referring to the single agent and LLM as a multi-agent?
See, basically, LLM is common across either a single or a multi. Okay, so basically, you take as a human being. Now, intelligence is common for all of us, right? Intelligence will not vary. I mean, like Neeraj may have a different intelligence, Prashant may have a different intelligence, but again, at the end of the day, as a human being, we all have intelligence. That intelligence is LLM here. Now, doesn't matter whether you're working as an individual or whether you're working as a team, your intelligence will not change based on the scenario of what you're working upon, because that is the knowledge with which you're going ahead with. Okay. Now, in the same way, even you're using single agent or whether you're using multiple agents, ultimately LLM is actually required for here to just give that intelligence. That's just to set up the context, just to understand and process whatever you're trying to ask and give the relevant output out of it, Neeraj. That is the only significance of it. It doesn't vary based on whatever AI agent architecture we are using, either single or either multi-agent.
So SLM also can be multi-agent,
Exactly.
only maybe
Huh.
not the complex task, right?
Exactly, exactly. That is the right
Okay. So
one. That is
one
very
one more question, Prashant. So as you know that now the Chat GPT and other GPTs also come with their agent role also, right? So we can
correct.
see that there is
Exactly.
agent. So is it a single because they have also custom GPT options? So is it we can consider as a multi-agent or single agent?
It, like say, when you want to create an agent over there, it will ask you to provide the instruction, right?
Yes.
You have to
Yes.
give the instruction. Now it depends on the instruction how you give. Let's say you say the instruction like, okay, you create an agent in such a way, like first it has to summarize the document for me, then again later it has to write a mail, after that it has to send the reminder. Now you give three action items to do that within a single agent, then automatically it will become a multi-agent. Let's say you create that agent and say summarize me the document and give me the information. Then it is a single agent. It all depends on what action items you want, Neeraj. Accordingly, then it is going to work upon.
Okay, so that means when we create a custom like GPTs, it can be single, it can be multiple, depends upon the
Exactly.
objective of that.
Exactly. That is what is the outcome. Okay.
Okay, and sometimes the platforms like that not like a chat GPT, other platforms they say that we are not using your data for the learning purpose, right? Maybe due to the compliance and something. So if they are
Understood.
not using as a learning purpose, is it like that means there is no reinforcement learning? Is it they are not going to use the data for that? So
That's
how is it
false.
different?
That's false. That is false. They are doing it. Otherwise, without knowing the you, how are they saying that next time when you are trying to interact with it, hi Neeraj, welcome back. How are they getting to know your name and all? So they would say like that. That is the reason we will talk about all these things in security, ethical aspects of it. They
Yeah.
take some part of your data and they will do reinforcement learning, understanding who you are, and then next time when you see your responses will be very much fine tuned to who you are exactly. So it happens. Even though they claim that it is not, they still keep training with your data, with whatever you
It's
supplement or whatever you
okay,
give
so
it.
it's a gray area basically, right?
It's gray area, exactly. That's where guardrails play a very important role. Okay.
Yeah, yeah, yeah.
We'll
Thank you.
talk about that in security part. Huh? Thank you,
Okay,
Neeraj.
okay.
Yeah, one last question. After that, we'll go for a break, everyone. Anirudhu?
Yeah, hi Prashant. So, like we were just discussing, if a company wants to keep its data secure, is the only option to save the data in vector database, or
No.
there is another option as well?
See,
If it doesn't
basically what
work,
happens is, yeah,
uh
basically what happens is, company can always say, let's say to OpenAI like ChatGPT, see, I don't want to host any data on your server. I have my own server. I have my own IP address. I will not send any data to you. But only thing what I want from you is you please come and then make sure that whatever capability you have, like you have a great computation power, you have a very good intelligence, you already have been trained with a lot of data. So what I want is you give me only these services. Okay, data storage will be done in my database, data will be there in my network only. So you will configure in such a way, either using a cloud or either using your infosec, your information security team. You're gonna put your security in such a way, every IP address, everything belongs to your network only. You always going to communicate within a virtual private network, VPN. But still you can use the services which these LLMs are providing to you. Today, that is the model how Aniruddha it is working. What is happening is, like, let's say you can still use your own infrastructure, but only whatever the capability which these LLMs are having, you can just take it and can leverage it. Like they have a very good intelligence. You only use that, but you are not going to dump any data to it, or you're not going to send any data to that particular part. It will be all your network only. It will all be related to your IP address. It is all related to your server. Everything is present in your network, but you're not going to integrate with other existing applications. So that's the major idea, is what I just want to make it very clear to you. Is that clear, Aniruddha? Okay, you gave me a thumbs up. Perfect. Okay, cool. So I know remaining there are some more questions. It doesn't mean that I have just ignored it. So we'll go for a break, because as you know, right, if I keep on answering, then we will not be able to move on to the hands-on activity. So what I will do right now is we'll take a small break. After the break, we'll come back and we'll try to do some practical implementation of whatever we have been able to learn till now. And whatever the pending questions, the people who have raised your hand, somewhere again I'll see some small gap, and then I'll try to come back and we'll try to answer all your questions. Okay, if not, I'll try to answer it at least at the end of the session. I'll make sure that all your questions are being resolved. Okay, let's take a quick 10 minutes break, everyone, just a small refreshment. And once we come back, we'll move on to the practical part of it, and we'll try to understand like how a single agent would work, and then how a multi-agent is going to work upon, and then we'll be able to move ahead and try to take up different questions associated with it. Thank you, everyone. Let's take a small 10 minutes break. I'll enable the timer very quickly here. Okay. Welcome back, everyone. So now it's time for us to do the quick hands-on activity. People who have mentioned in the chat, okay, I have answered most of them over the breaks time. So I hope you all have got some clarity. Hey, I gave you a chance, Trisha. Okay. But that time I did not get a chance to hear from you. So I'll give you again a chance. People who were missed out, please don't think that we are ignoring, because we have a very limited time to take up the questions. Okay. So as it is not a question answering session, so I can only take up limited questions at a particular point of time. But still, if there are any further questions, I'll be able to give you all the chance and you can ask me. Okay. And again, just not right now. Let's focus majorly right now on the, let's say, whatever we are discussing as part of our let's say the hands-on activity. Let's try to complete them, and then probably after which, if there are any questions pending, we'll be able to take them up, and then we'll be able to proceed further. Okay, so that's the major idea, everyone. Okay, let's now go ahead and get started, everyone. Let me let us get started. Give me 1 minute. Let me explain to you the problem statement of what we are going to discuss right now. So currently, everybody, let me explain to you the problem statement of what we are going to work upon. And then after that, we will be able to proceed further. Okay. So the problem statement with which we are going to work upon right now is, like, as you know, right now, let's say we are going to create a very simple sort of an AI agent. Let's say uh, currently today we are targeting the healthcare sector, I would say. That is what our primary focus will be. Based on whatever we learned today, we'll talk about the healthcare sector, everybody. Now in the healthcare sector, right, let's say like currently many patients, they feel confused, okay, or they really feel scared when they experience health symptoms like, let's say, a chest pain or some shortness of breath, okay, or maybe like a dizziness, especially when doctors or hospitals are not immediately available, right? So for them, this application, whatever we are going to build, is going to be really helpful. Okay, so what we are trying to do here in this case is patients who are like, basically, I would say patients who are basically scared in the process, like if they have like some of them may have some chest pain, okay, or maybe it may be related to, let's say, shortness of some breath, okay, or it may be related to dizziness. So anything like that, if they have some concerns, right, that's going to create an impact to them. So especially when doctors are not available. So now what we want to do is we want to build, okay, we want to go ahead and build really an AI powered assistant. Okay, that's what we all are going to work upon. So we want to get rid of this problem where we want to really bring up an AI powered assistant. So basically what this AI powered assistant has to do upon right now is the AI powered assistant should first go ahead, understand, okay, it should actually understand using the perception module. It should understand that what the patient is actually feeling. Okay, it should understand that what exactly the patient is basically feeling right now. That's the first thing. Okay, then your AI powered assistants also should be first able to understand what the patient is feeling, and then at the same time it should also be able to check, okay, it should also be able to check whether if the symptom whatever is being provided, okay, whether it is serious or not, okay, whether if it is really serious, it should be able to provide you that information. Okay, then after that it will also be able to go ahead and guide you in terms of giving some suggestions. Okay, so once it analyzes, then it will go ahead and will try to suggest like what the patient should do next. Okay, it will suggest the patient, okay, that what you have to do next. It will give that suggestions, and then all of this will be given in a natural language which we can all be able to understand it. Okay, so basically what are we trying to do here, everyone? So we are creating an AI powered assistant where it should first understand what the patient is feeling, then it should check if the symptom is really serious, and then it should suggest to the patient like what they need to do next, like either they need to visit the doctor immediately or visit emergency or take some rest. What is the suggestion it has to give? And finally all this can be done like you can use this AI powered assistant at any point of time. You don't have any restriction or a limitation. You can just use this and everything will be given in your own natural language. Okay, so this is more like a basic health chatbot we are going to create, where we will leverage the Google Gemini, like whatever the API which we have created yesterday using the Google Studio, right? AI Studio. So same. So that API key only we will use. We are not going to create multiple times multiple API keys, because that doesn't make sense. The same API key you can leverage it, and then the Gemini will take the symptom message from the user. It will analyze whether if it is serious or not, and then it will give its advice in a very in a very simple manner, so that we all can be able to understand it in a better way. That's the major thing which we all need to understand right now. So what am I going to do in this scenario is, let's go and try to understand the functionality of how we can like make sure that this particular problem we are trying to analyze, and then we are trying to like utilize it with the help of the like a program. Okay, we'll implement the program and then we will take it up to the next level. So this is the problem statement which we are all going to work upon. Okay, so where we will go ahead, create an AI powered assistant which will help us out in all the different areas which we have targeted right now. So let me take you to the Google Colab, everyone. So as you know, the Google Colab is going to be the best source to complete this activity. One best thing is it's more or less like what we already have discussed. Okay, yesterday it's more or less towards those lines only, but yeah, the use case is little different right now. So the first thing, if you see here, everybody, the first line, if you see right in this scenario, so this is like what are we trying to do here in this scenario is like if you observe, we are installing the Google generative AI. So this line will install the Gemini AI library. Okay, whatever the Gemini AI library which is required, right? We are trying to install that over here. So we are simply saying that, hey, get me the Gemini tool from the internet and make it available in my Google Colab so that I can be able to leverage it. That's what we are actually trying to say here. And if you see right, why do I use this exclamatory at the start? It indicates that it's going to act like a, instead of a code, this is going to act like a command. Okay, where you are going to see that we are installing the Google generative AI, because we are going to leverage the what Google Gemini, right? So obviously I need the Google generative AI to be installed, and it should be available in my program, whatever I'm going to utilize it right now. So the moment I complete this part, like once the installation is being done successfully, then what is that I'm going to do here is I will import my OS. Okay, so I'm going to go ahead and import the OS over here. So when I say import the OS, so what does this mean? So it will bring in all the Pythons, right? Whatever Python file system is there, everything is going to be imported over here. The moment you say import OS, so this is where all the Python's file, okay, whatever the Python file system is there, everything is going to be taken into consideration. So I'm just saying that I want to use all the Python's tool. Okay, whatever the Python's like tool is there to work with files and folders, right? For that you need OS. Okay, so if you want to work within the Python where it can handle all your files, and if you want to make it handle all the folders and everything, so definitely you need a import OS. So import OS will make sure that you will see that all your Python files and folders can be handled appropriately. Okay, and then later what am I trying to say here is, everyone, if you observe, I already installed in my first step what Google generative AI. I already have installed it successfully. Now I'm saying that the moment I have installed my let's say the Google generative AI in this case, I'm just giving it a short name here. Instead of saying Google.generative AI, I'll just simply call it as the Gen AI over here. Okay, instead of Google.generative AI, I'm just like just saying that I want to name this as the Gen AI. So, but like we are bringing in all the Gemini AI functions with the help of the Google.generative AI. But wherever I want to leverage it, I want to use this short name as a Gen AI over here. That is it. So that is the main idea over here. So what we're trying to do, first we are installing the Gemini AI tool in our particular program. Then we are handling this OS, which is required to in Python to handle all the files and folders. Then we are importing that Google generative AI, and we are putting a short name for it as a Gen AI over here. That's it. Now, what is the next step we are trying to do in this case? This is where I'm integrating my API key. If you all remember, yesterday we have already learned how to create an API key, okay, in the Google AI Studio. So whatever API key you would have created it, right? Just copy that API key and replace that over here. In the Google API key, I would request you to replace with your API key, okay? So that is what you all need to do. And remember one thing, everyone, API key should not be shared with anybody, okay? It is something which is confidential, and don't share it with anyone, because unnecessarily they will leverage your API key, okay? Don't try to share your API key with anyone. In that way, what will happen is, like, as if you don't share any of your API key, it's always good, because they may go ahead and use your API key, and again, you have to pay the billing for it. So better not to share any API key with anybody. Okay, but this is a secret key. This is like a secret key. Let's say you will interact with whom? You will interact with Google Gemini. Now Google Gemini will say, if I want to validate and allow you, I need an authentication mechanism. So that authentication mechanism is going to work with the help of the API key, everyone. So with the help of the API key only, you will be able to get yourself authenticated, and you will be integrated with your LLM. Okay. So to to have that authentication, like how we enter into an application using the password and all, in the same way, if you really want to integrate with your Google Gemini as an LLM, you need an API. That API will play a very important role for you to integrate into the LLM world and then try to have whatever interaction you want. Okay, that is how the system is going to work. So that is where API key will be required. Like how you provide password for different accounts to get yourself authenticated and get validated, and then you will be allowed to enter into that application, right? In the same way, if you want to interact with Google Gemini LLM, you need API as an authentication to proceed further. That is the reason, as long as API is not there, it will not allow you to integrate with any of your existing LLMs. So that is a core idea we need to be here aware about. Okay, so here is where we are saying that use the Google API key. Okay, use the API key, whatever I provided. See, Google API key is a variable here. I'm saying that please configure, okay, please configure or take the API key, whatever I have highlighted here. So that now what will happen is this will take the API key and it will authenticate, and it is going to allow me into the Google Gemini ultimately. Okay, so that's the main idea in this case. Now within the Google Gemini, okay, within the Google Gemini, now I'm going to use a model called as the Gemini 1.5 Flash Latest. So this is the model which I'm going to use, everyone. Okay, so what is that the model we are going to use? So the moment you enter into your Google Gemini LLM, so every LLM is going to have a different models present inside it. So now one among them which we are going to use here would be the Gemini 1.5 Flash Latest model. Okay, and we are saving this model within a variable here called as the model over here. You see that here is the variable which is called as model. So within that, we are saying that I need a generative model, and that model name is Gemini 1.5 Flash Latest. So this is what I actually want. Okay, so it's like let's say LLM is a brain. Now within that brain specifically, I need this model. Okay, I want to use this Gemini's like 1.5 Flash, which is the latest and then the fast one. So I want to use this model in order to generate the output, whatever I required for my case study. Okay, and then what happens here, you see that chat equal to model dot start. Okay, what does this mean? So here we are saying start the chat session. Start a chat session using the Gemini model which I mentioned, and you can name it here as a chat in this case. Okay, so what I'm trying to do is, like with this, we are opening a fresh chat window with the Gemini so that people can ask whatever the questions they want and they can get the answers. That is what we are enabling over here. And then if you observe over here, what are the two things we have done in this scenario? One is we are asking the model what we want to be leveraged, right? This is like a intelligence of the brain which is going to work upon. So within the LLM, I need the Gemini 1.5 Flash Latest, which is very fast and smart enough. And then we are saying whatever the conversation we are going to start with the doctor, that will get started with this chat itself. Okay, now if you see here, the next important part in this scenario is this is a user input. Wherever you use input like this, right, that means you're asking the user to input. Okay, that means the one who is going to interact with this application, right, they are going to provide the input. If you are interacting with it, you need to provide the input. If I am interacting with it, then I am going to use the input here. So basically, when you say in this scenario input, okay, input means it will show the message to the user, like what are the health symptoms or the problems you're facing. And then it is going to wait for the user to type the response. Okay, so now because obviously AI agent or any let's say any AI, it's not going to enter into your mind and then it's going to give a response, right? So you definitely have to make sure that you're going to get the response whatever is required. Okay, so that's the major thing which we need to understand. So basically the approach or the understanding is like for an instance, if I would make it very clear, let's say whatever we are trying to analyze, okay, whatever you're gonna make it as an input, so you have to give that, like, hey, this is the problem you're suffering from, and then it's gonna give you the response accordingly. So that's how we need to give an input, like what is the health symptom or what's the problem you're facing from, and then accordingly it will be able to generate the relevant response to all of us. That's the significance of an input, like where you can go ahead and say that what is the problem you're trying to suffer from, and then it should be able to guide you accordingly. Okay, this is where input will be given. Like the moment I execute this program, right, it will ask you that, hey, please describe your health symptom. that is the significance of actually having the input present over here. So we are asking the patient to type, hey, what are you feeling right now? So that answer will be saved to Google Gemini, and then later what it is going to do here is, let me try to little bit take it further. Yeah. So now you see that what is going to happen in this scenario is, everyone. So let's say you say that, hey, I have some, let's say, like for an example, chest tightness, or I'm having some breathing problems, something like that. So you can be able to provide your user input. So then what will happen here is, as a next step, okay, as a next step, what it will try to do is, this line, whatever you see, right, response, this line will be sending the message. It will take the input, whatever you have provided, it will take that message to the Google Gemini. So what did the patient say? The patient, whatever they have said, will be noted here as a user input. Okay, that is nothing but here the variable. So whatever you are going to pass here, that will be taken up dynamically. So whatever you are going to give as an input, right, that input will be here taken up dynamically, everyone. So the patient says, and then dynamically whatever you want, that dynamic value will be picking up, and then it will analyze, is this a serious medical condition? And then what should they do next? This will be taken to your Google Gemini, where whatever the user has been able to provide as an input will be taken. It will be analyzing whether if it is a serious medical condition, or whether what they should do next actually. Okay. And then it then waits for the Gemini to think and reply, and then stores that reply in a variable called as the response over here. Okay. So I will say, simply I will print something called as an AI advice. It just prints AI advice. That's it. It's not going to do anything. It will just print whatever is present in the double quotes. That is AI advice. And then later I'm saying, hey, print me the response. Response is what? Response is what you're getting from the Google Gemini. So I'm saying print the response.text. So basically this is going to show you the advice. Okay, this is going to show you the advice from Google Gemini in a basically in a very natural, or I would say in a very plain language, we are going to see the response. So it will say, hey, this could be serious. Please call emergency services and rest while waiting for the help. Something like this it will try to say. Okay, so what are we trying to do here, everyone? Basically, if you see this entire program over here, if you see this entire program, right, what exactly it is trying to do from the top to bottom, if you can be able to have a look into this understanding, right, it's a very simple, but it has a lot of effective output over here. First, we are trying to get the Google generative AI, because we are using the Google Gemini as our API key. Then we are importing OS to handle all the file systems in the Python. Then we are trying to say that, hey, I want to name this Google.generative AI in a short form called as a Gen AI. Then I'm using the API key which I have already created yesterday. So I can take that API key and it will authenticate me to the LLM, that is a Google Gemini LLM. So I'm using that API key to authenticate myself to the respective, let's say, to the LLM, whatever we want. And then here we are mentioning the model, like this is my model which I want to use. So the model which I want to leverage here is Gemini 1.5 Flash latest. So this is the model which I want to use. Okay, and which is very fast enough, and at the same time it gives you some really good information. And then this is where the chat conversation will start. It will begin, because it's a chat bot, so definitely chat conversations are required. Then until you don't provide the input, we are not giving the AI to assume and think everything on its own. Okay, we're not giving that capability. So instead what we are saying is, as a patient, you please provide the input, like what are the health symptoms you are trying to observe. So the moment you go ahead and then try to provide the input, okay, the moment you go ahead and then try to provide the input, what it will try to do here is, everyone, so in the response, okay, it will take your input and then it will send it to whom? To the Gemini, because we are integrating with the Google Gemini. So whatever user input will be provided here in this above step, that will be taken up dynamically. So it will say the patient says that they have a problem with some breathing, let's say. And then that will be taken up to the Gemini, and it will say, is this a serious medical condition? It will ask, the Gemini will analyze it, and then it will give you the steps that what you should do next. Then simply print here saying an AI advice here, and then simply print the response. So whatever the response which is being generated from the Google Gemini, it will be printed in the form of a text pattern in a very plain language which we all can actually be able to understand it. So that's the major idea we need to be here aware about. So what am I going to do once this part is completed successfully? Okay. Once this part is completed successfully, what am I going to do is I'll just try to run this, everyone. Okay. You have the option to run over here. So the moment you go ahead and then try to run, so let's see what it will try to do for me first. It's just executing. First, it will try to install the Google generative AI. So you see that here, it's just trying to install everything in my system. Now see here, everyone. It's not just giving the output. It is asking me that, hey, please describe your health symptom. Like what is that you are facing as a problem? So you please go ahead and provide that respective health symptom is what it is trying to ask me right now. So now, I mean, I have all the liberty to go ahead and then try to provide whatever the health symptom I am facing. So I can just say that, okay, I can just say like, I have chest tightness, something like this. I have chest tightness and trouble in breathing. Let's put a difficult situation. Let's see what it will do. Okay. So let's try to click on enter. So I just gave my problem. I have chest tightness and trouble in breathing. So here, it took the user input. This is my input. So now it will take this input and it will go to the Google Gemini, and then whatever analysis it has done, it should be able to print us. That's what we have mentioned in the code. So let's see. Okay, wow, it gave us C. Now it just says that, okay, so my advice here is like chest tightness and trouble breathing can be symptoms of serious medical condition. So it analyzed under the category of the serious medical condition, everyone. Okay, and then it just says that the symptoms can be very serious and please don't try to ignore this. Okay, I don't want you to ignore this, is what it is actually trying to let you know. So what it is trying to say, first, please call for help immediately. Okay, call for help immediately. So if it is, it's just taking default US, you can just put it in Indian part, like you can call 108. Okay, it will just asking you to call the emergency medical services immediately. Do not try to drive yourself. Okay, so do not try to drive yourself is what it is trying to say. And then it is also letting you know that let the ambulance come for you. Okay, and then while you wait for the help to arrive, I would see, it just says that I mean, don't panic. Okay, so it just says that, hey, you just don't make yourself feel panic, just be calm. Okay, and like it's just letting you also know that, I mean, some of the different approaches like where it says chest pain or a pressure like dizziness or lightheadedness, irregular heartbeat, anything as such is happening, it's just asking. So if the patient is able to, they should sit upright and relax. So it's just giving you some suggestions. Hey, don't panic. Okay, sit upright or lean forward slightly. This will help you to breathe a little easier. It's just saying you that part. Okay, and like it also says you that like if you have prescribed, if there, I mean, if you have any inhalers for asthma or COPD, you should use them as directed by your physician. Okay, it's just giving you some different approaches what you need to do right now. Okay, so and then it also says you that, hey, just be ready to explain to your like symptoms in a very clear manner the moment your ambulance is being with you. And then this is not a final diagnosis. It just says that, hey, this is not a final diagnosis I'm trying to provide to you. It's just an advice. It's just an advice which I'm trying to describe to you. A real doctor will actually examine and they will be able to confirm this to you. But based on whatever you have been able to provide to me, this is what I'm going to let you know so that you can just be very clear that what exactly is happening in the process. Okay, you can just be able to go ahead and identify and understand that what exactly is happening. So let's say if someone says that they have chest tightness and trouble breathing, AI will immediately flag it as a serious concern. It is doing that. It's immediately flagging it as a serious medical condition. And it is also at the same time giving you some calm and clear steps. It's asking you to call for help. And it is also saying you that what are the regular medicines, if you have, take them, wait for the doctor. Okay, so it does not try to guess. It always comes up with a real help, like how you have to proceed further with. So this is how it can just take the user input from you and can be able to come up with the best output which can actually be able to guide all of us in the entire process. Okay, that's the major idea which you all need to be here aware about. So what am I going to do here is I'll be sharing this code to all of you, and I would request that you please go ahead and change the API key. Okay, so how would you create an API key, everyone, as I already discussed yesterday with all of you? Okay, so let me quickly go to that particular site. I think Google AI Studio. So let's go to the Google AI Studio. Already yesterday you created the API key. I have explained to you, right? Just once you enter into your Google AI Studio where you have the API keys available, scroll down. Here is where you'll see your API key. Okay, at the bottom, click on this API key like this and copy. Just copy your API key and then add it in your the code whatever we discussed in the Google Colab, right? I would request you to please go ahead and add it over there. That's the main idea. Okay. So you have your API key like this. Just click on it, copy, and then save your API key here. Like just go to your Google Colab, okay, and then you can be able to paste it over here. So let me share this code to all of you over the chat, and I would request every one of you to please practice, and then after that I will explain to you the how we have to integrate it with multiple agents. Okay, and just leaving the Google API key empty within the double quotes, that's where you need to put your API key, everybody. So otherwise let me share my API key, that's fine. Like just give me 1 minute, so that what will happen is if anybody who is interested at least can use my API key. But the only problem is, okay, better no. Better we'll do one thing. You only create an API key, because in that way you all will be learning how to create your API key and you can leverage it. Okay, give me 1 minute. Let me remove this key. Okay, I just shared in the chat, everyone. So I would request you to please go ahead, utilize this code in the Google Colab. Yesterday I already explained to you that how you have to open your Google Colab. Please go there, try to implement this code, execute it, and check the output, everyone. Check the output. That first it should ask you to describe your health symptom. Please provide your health symptom, whatever the problem you are facing. Then Gemini should be able to analyze it and should be able to give you the relevant output associated with it. Okay, it should be able to go ahead and give you the information. First it will install, and then it will take the input from you. It will analyze and will segregate whether if it is a serious or a normal medical condition, and it will give you the advice that what you actually need to do. So even though there's no doctor available 24/7, it will assist and guide you. Again, it will also say you very clearly that whatever it is knowing, it will try to help you out with it. And until the real doctor is coming, you can at least go with these steps. The moment you see the real doctor is there, then you can like discuss and interact with them and can get all the measures whatever is required. So please complete it, everyone. I'm gonna give you a couple of minutes or maybe 3 minutes for you to please go ahead and complete this step. After that we will proceed with the next one. Okay, complete this one, everybody. Everyone, I shared the code in the main chat, okay? In everyone, tagging to everyone, I shared the code in the chat. So please, you can take the code from there, okay? I shared it to everyone in the system where you can be able to go ahead and can utilize it. Everyone, there were a couple of questions on related to instead of giving the API key, can we configure? Yesterday, I already explained to you that flavor. Today, I'm explaining a different way. In both the ways you can do. Okay. You remember yesterday I imported the security key here. So yeah, either you can practice in this way or either you can use your API key also like this. However, it is comfortable for you. You can leverage in whatever way it can be. Is everybody done with this? Can I explain to you the multi-agent approach over here? Just please quickly complete this one so that I can take you to the multi-agent architecture, everybody. That how the multi-agent architecture is going to play an important role. Now, whatever we have seen, this is more or less similar to like yesterday only. Right? Yesterday we have done one last program, right? That was related to a general question. Can you explain the difference between the agentic AI and all we asking question? Here what we are doing is we are giving the user the input. Okay, that where the user can provide the input and you will be able to take it to your Google Gemini, analyze and then give the response. Okay, more or less like that. But when we go to the multi AI agents, so you will be able to see there would be some good scope out of it. Okay, so complete this one quickly and then accordingly we'll be able to move ahead. The people who have raised their hands, I cannot take up the questions at this point of time, so please bear with me right now. The only reason is if I keep taking the questions, right, it is taking away a lot of time. So just wait. I'll complete up the multi AI agents. With that, what will happen is whatever is intended for today's session will complete it, and then I'll take up again all the follow-up questions, whatever you have, and I'll answer. Don't worry. Until I've not answered, I'll not close the session for sure. So please, I know that the people who have raised your hand, just bear with me for some time so that I'm answering over the chat also. Over the chat, I'm trying to type and putting the answers. And the people who raise your hands, I'll give you enough time once we complete the multi-agent architecture program also, and then I'll go ahead and we'll take up all the relevant questions, whatever you want. Is it done, everyone? Anyone else who's still doing this? One thing, everyone. Again, I just want to make it very clear over the chat. Whatever I'm observing, I'm trying to say. Okay. See, what I'm trying to say is yesterday we did from the Google Colab import the user data. That is also fine. You can leverage even there, like where you can secure your keys here and you can do. See, now people may ask me, how do I know I have to use start chat? Start chat is meant for starting the chat, right? Maybe this type of questions will definitely come up. The only reason is you need to know, as I said, right, Python as a prerequisite. When you know Python as a prerequisite, you know some key functionalities which are required, and all these things gradually you will learn when we move forward with a different set of programs. So let's say for the first time, if you're learning, definitely you will not know what is what. But gradually, when we keep learning the same set of programs, let's say for an example, the best thing I'll say, yesterday you have done similar sort of a program. Yes. Now the moment when I explained the same program, it did not feel a lot of overwhelming to you. Why? Because the same pattern we already discussed yesterday, everyone. So now it felt like little not so overwhelming because you know the same type of a model we have discussed yesterday. So gradually with the learning, you will understand that start chat is nothing but to start the chat in the Gemini model. Okay, what is a Gemini 1.5 Flash latest? How to configure the API key? Okay, how to install the Google dot generative AI. So all these things gradually, once you keep doing the things, you will automatically be able to practice and you'll be able to get to know with regards to it. That's the major idea which we should be able to where we need to go ahead and handle it appropriately. Okay. Yeah, and one more thing, everyone. You can see. Remember one thing. If this is a sample, this is a sample. Now you can always enhance it. You can always enhance it. Just play around, do some mistakes, do some trial and error approach, and see whatever suits your requirement. Like for an example, now I kept the input as please describe your health symptoms. Now this became the healthcare case study. Now instead of saying please describe your health symptoms, now you say please describe your fitness goals. Now you can use it for your personal benefit, everyone. You're getting my point. Instead of leveraging some external tool, now you can create your own program and use it in such a way. Please describe your, let's say, fitness goals. Now you can just change here the wording. Okay, you can say my fitness goals are user input. User input is the input what you provide. Okay, and just say, is this a like is this a serious medical condition? Instead of say, is this a right fitness goals? Okay, if not, let me know what I need to do or what should be my next steps. You have to give some instructions like this where it can also be able to work not only related to healthcare. As we are right now talking about healthcare, I'm limiting to it. But imagine if you have something else, like where you don't want to leverage it for healthcare, you want to leverage it for something, some other purpose. You can always feel free to go ahead and utilize it. In that way, it is also going to be more beneficial to all of you, which I would say, everyone. Okay, so you can leverage one single code into multiple domains and areas where it can be helpful for you all in the long run. Okay, now let me take you to the next important thing, everyone. Okay, let me take you to the next important point here is how we can leverage it multi-architecture. LLM are all the owners sharing data with corporate because in this case, okay, Prabhu, what happens is it's not something like where I mean, it's not so easy like where we are trying to share the data. Like if you remember this morning, somebody has asked me this question, right? Organizations will always try to host everything in a closed network, which we call virtual private network, called as a VPN. Within the VPN only, they would try to allocate and add everything within it. They don't want to give away the data to anybody, right? They will say, we will have our own network. We are going to host our own data in my server. What you have to do as a co-pilot or as an OpenAI is you have to come to my network. You have to come to my network. I am not going to come to your network. So because for OpenAI it's a business, they need money, so they have to follow. They'll say that okay, we'll come to your network, whatever capability we have, we are going to provide it to you and you leverage it. But all the data and everything will reside in your organization because it is your private network. You're getting my point, right? So they are not going to agree that I will come and sit in your network. Instead, they will come and sit in your enterprise network so that they can give you all the benefit of whatever they have as a capability. That's the major idea. Okay. Okay, cool. Let me now take you all to the next important topic which we need to consider over here. Okay, so now what am I going to do here is, everyone, let's now talk about a multi-agent approach, like how as a multi-agent we can be able to go ahead and leverage this entire system. So I'm going to give you again a problem statement for the same healthcare domain only. We are not going to do anything different over here, but what is that we are going to learn here, like I mean as a problem statement, how this is going to play a very important role. We'll try to just experience it right now. So let me take you to the whiteboard. So now if you see that same scenario, nothing would change here. Okay, same healthcare. Okay, same, like you are going to provide what problem you're actually facing, same things only, but now how it is going to work, I'll just let you know. So let's go ahead and quickly try to understand that. So now what we are going to do in this case is we will just make sure that we are using the multi-agents. Okay, we will try to go ahead and try to leverage the multi-agents in the system. Now these multi-agents are going to play a very, very important role to do what? To first of all, you have to describe your symptom, what you are facing. Then you will see the AI generated summary. Okay, it will provide you the AI generated summary. Then it will guide you with some next step, what it needs to do. Like it will give you some next step suggestions which are going to be helpful. Then it will ask you some follow-up questions. Okay, it will ask you some follow-up questions like what problems you are still further facing, and whatever you discussed, right, everything is going to be noted and it will be saved in a document. Okay, everything will be noted, and AI agent will automatically create a document so that it will be like a proof, whatever the discussion has been done. So everything will be created as a document. So now we are creating a multi-agent. First, where you're going to describe the symptom in a natural language. Then the AI will generate the summary based on the symptom what you provided. Then it will give you then what are the next steps or suggestions which you need to incorporate to get rid of that particular problem or the symptom which you are facing right now. It will ask you some follow-up questions like how a doctor asks, right? Let's say you say that you are facing this problem. The doctor may ask you like any previous like medical history or what has happened recently. So to analyze in a better manner, right? And then finally, the AI agent will be able to create a document also. That is what is going to happen right now. So in order to do this successfully for all of you, what am I going to do in this scenario here is, okay, 1 minute. So yeah, okay, let's now talk about it. It's a very simple, but it's very cool and neat, I would say. Okay, it's very simple, but it's very cool and neat is what I just want to let you all know here. So just try to understand the sequence, the flow, and the logic. You will really like the code. Okay, like how multi-agents can be created, everybody. So first step, what am I doing? So this is not something which is new for all of you, because this is a step which I already discussed in my previous program to all of you. So what is that I'm trying to do in this case? Obviously, when I'm going to leverage my Google Gemini, so what I have to do? I have to install my Google generative AI in my system, right? That is what is required, because that is going to go ahead and install my Gemini AI library. Whatever the Gemini AI library I need, I will install that in my system. Okay, and this is your Google's AI model. Okay, and quiet means what? Why? See, this is optional. If you want, you use it. If you don't want, that's also fine. Quiet means it will just hide, like whatever installation it will do, right? All those messages which will come. So all those messages will automatically be hidden. Once the installation is done successfully, it will say installed Google generative AI, rather than all those long text which is required for you to see what all steps it is trying to do. If you don't want, you can say quiet, that it will not give you all those steps. It will just simply say I have installed the Google generative AI. That's it. It will not go through all the details associated with it. Okay, that's the major idea here. Now, you know this import OS. Why I need import OS? Like OS will always let you interact as a Python library to manage if there are any files, if there are any folders. So if you really want to interact and manage with it, so for that you need your OS to be imported. Okay. Now, then I'm saying that from date time, I need to import a date time. What does this mean, everyone? See, basically it is just saying that date time. Okay, what date time is basically a library. Okay, now what this date time will do, you know, everyone, it will try to fetch the current date and the time. If you really want to fetch the current date, okay, if you really want to fetch the current date and time, so you need to get the date time into consideration. Okay, so what you need to do here is you just need to import your date time. So date time is nothing but it is one of the library, where using this date time as a library, we are going to fetch whatever the current date and time which is required, right? All that current date and time will be picked up by this date time. Okay, that's one of the library. Whenever you are using the date time, it will simply say that, hey, I'm going to fetch the current date and time which is required. At this point of time, whatever the date and time will be there, it will automatically be registered over here, everyone. Okay, so if now this is something which you already know. Wherever you know, I'm not gonna invest a lot of time there, because you know you are importing the Google generative AI which you already installed, and you're just putting a short name for that as a Gen AI. Okay, then here is where we are trying to use the API key, just as we discussed in our previous program. So you see that you can provide your API key, which you have been able to create it from the Google AI Studio. So you can leverage that API key over here, and you say that please utilize my API key as an authentication mechanism for me to validate and then enter into the Google Gemini. Okay, once that is completed, then we are making it very clear within the Google Gemini, I want the model called as the Gemini 1.5 Flash latest. So this is the model which I want to use within the Google Gemini, so that it can be able to assist and then guide. Okay, so that's the major thing which we need to be here aware of. Okay, so where it will assist us by letting us know what respective model we need to integrate and how it is going to play an important role is what you will see here as the AI model. Okay, now these things obviously, like more or less we are aware about, like these are some prerequisites, like where we need date and time, where we need OS to manage the files and folders, where we need to have an API key to authenticate ourselves, and then this is the model which we want to leverage it. Okay, till here everything is completed, everyone. Okay, now what is that the next steps we need to follow here? Okay, let's go ahead. So first one in this scenario here is you have your agent one. Okay, the agent one, if you observe here, this is only the agent one. Like we are talking about the multi agents in this picture. Okay, where you are going to really have like different agents being involved over here. So first step is multi-agent. In that first agent we are discussing no team lead concept, no hierarchical concept here. Every agent is equal. That's what I said when I was explaining the concept, right? Practically when you will do, you'll understand it. The agents will work logically but not hierarchically. Okay, so let's say for an example, I'm going to create a function. So in Python, whenever you want to create a function, you define it with def, and then the function name is symptom agent for me. So you need to provide an input text. You have to go ahead and give your input. Okay, where it will take the user's health. So let's say it's a input which you need to provide, that what is the health symptom as an input you want to provide. That is your input text. Okay, then what it will try to do here is like whatever the input you have been able to provide. Okay, first it will print saying that, hey, as a symptom agent I'm going to work now. Okay, and then later what it is trying to do is, this is your main step in this entire agent. This is the main step which I kept in the square bracket here. Okay, so what is going to happen here is it will send the symptom, whatever the input you have been able to provide here, that input will be provided right now to whom? To the Google Gemini. Okay, here see the dynamic variable, whatever input text you are passing here, that will be provided here. So you are saying classify the severity of the symptom and list all the possible conditions based on the input whatever is provided by the user. So you are giving this as a prompt or as an instruction to your Google Gemini, where your Gemini will go through by taking your input text, whatever you have added here in the symptom agent, and then it will consider this instruction, and then it will be able to guide you. Okay, it will try to see how serious is this symptom and what could be the possible health issues which could have actually come up with this. So then the Google Gemini will read and then will try to provide you a very detailed response out of it. Okay, so you are going to print here. Okay, so you are going to print in this case the response.text. Okay, that response.text is nothing but the response which you are going to generate from the Google Gemini. Okay, so whatever the response is present. Okay, so you will be able to see ultimately. Okay, so in this scenario, like whatever the Google Gemini is going to give the response, you will be able to print it. Okay, that is going to show you the relevant explanation. Okay, and then ultimately what it will try to do, return me the response.text, means it's going to give the answer back to you. Okay, it's going to give the answer back to the rest of the program, because rest of the program is also dependent on the symptom agent. Okay, so when you say return the response.text, means it's going to give the answer back to the rest of the program. So other parts like who are dependent, like scheduler agent, follow-up agent, they can see the response which is being provided by the symptom agent. That is the reason we are returning that. When you say return the response.text, right, it means we are trying to say whatever the output I got from the symptom agent, I want to cascade that to the scheduler agent. I want to cascade the same to the follow-up agent also. Okay, so basically in the symptom agent, you give the symptoms, whatever you are facing as a problem, it will be taken to the Google Gemini, and we are giving the instruction over here where it will take your input text and it will classify the severity of the symptom what you are facing. Then it is going to print you that response. Okay, then next it is going to print that response in the form of response.text, where it can understand what you want. And then it will return the result, which is coming from the Google Gemini. This is one agent. Then again, in the same lines, we have a second agent here. Now, what is the second agent, everyone? The second agent is a scheduler agent. This is the next function, where you have it as a scheduler agent in this scenario. Now, scheduler agent will take one input here, and the input is symptom severity summary, which is nothing but what is this? Which is your previous AI response. Okay, whatever the previous AI response you have, right? That is the earlier AI response, like whatever the agent one. This is how collaboration works. Okay, whatever the response from the agent one is coming, so that will be taken up over here. Okay, how serious the symptom was, which is determined by the symptom agent, right? That symptom agent will try to pass that result to the agent to, which is scheduler agent. So based on the severity of the symptom what you have, the scheduler agent will try to schedule the appointment with the doctor. Now scheduler agent, what it will try to do, everybody, so first it will print as a scheduler agent here. It's just a print statement, it doesn't have any significance. Okay, now what will happen, it just says, see, response, which is nothing but it will go to the Google Gemini. It will say, based on the summary, okay, based on the summary, suggest me the next steps which the patient has to do. And this symptom severity summary is nothing but here, whatever you are providing, right, that will be taken up. So this is a response from the agent one. So whatever the response you are going to see from the agent one will be visible over here. And that symptom severity summary will be considered. Okay, so let's say now that if you know that your symptom, if it is very serious, it will say the patient to do like some next steps like, hey, call an ambulance, go to the hospital, or book a doctor visit immediately, or maybe take a rest at home, like based on the severity of the symptom, whatever you have highlighted here in the symptom agent. So accordingly, it will give you the next steps what you need to work upon, and then it will print you that result as a response.txt, and then whatever the result which the scheduler agent is going to come back with, so that will be returned over here. Okay, you can return that response.txt in this scenario, so that you can use this response with other agents which are being present over here. Okay, then you also see here very clearly, okay, you also see here very clearly, there is something called as the follow-up agent, everyone. Okay, there is something here called as the follow-up agent. Now what will follow-up agent will do again? Now this is a function where you're not giving any input now here. You're not going to give any input. If there is no input, the brackets are going to be empty like this. Okay, now this is a follow-up agent where you'll just print it. Now you're going to send as a response to the Google Gemini, where you'll say that, hey, what follow-up questions I should ask as a nurse to understand the patient's condition in a better manner. Okay, as a nurse, what I need to ask to the patient based on the problem whatever they are facing. How will it get to know the problem? Because automatically it notes the previous two agents, right? All they work collaboratively. So based on that, your nurse can understand the follow-up questions, like, okay, the follow-up questions can be like, when did the pain start? Okay, is the pain spreading to your entire body? Do you have any like a previous medical track recorded with regards to whatever problem you are highlighting? All these can be the follow-up questions which your Google Gemini itself will let you know what you need to ask, and then it will print that response, and then you can also return that response appropriately here. And then you have a logger agent. Okay, you see that you have a logger agent here. Now what is a logger agent, everyone? What is the purpose of the logger agent? Logger agent, this is again a function. Okay, this is a logger agent where it is going to take some key things as an input for us. Now what are those key things? One is the name it will ask, and then it will ask you the patient ID. Okay, and then what the patient typed as an input text, and what is the Gemini's response. Everything will be captured. Now it is like a logs, like whatever interaction has been done, the Google itself or the AI itself is going to take that everything into a particular document. It will note everything as a proof, so that nobody can misinterpret or manipulate anything. So whatever interactions have been done, it will ask you the name, it will ask you the ID, the patient ID, the input text, and the output text. Input text is nothing but whatever you were able to provide, and output text is the AI response. So tomorrow if AI also does the mistake, we have a log which has been proved. Okay, and it will print just a statement saying that logger agent is recording the information. And now see log entry. How the log entry is going to happen, you know, everyone? The log entry is going to happen in a very formatted manner. In a proper format it is going to create. How it is going to create? See, first it will include the current time. What is the current time? It will provide it. Then it will provide the patient name. Then it's going to provide the patient ID. Then whatever the input text we provided, then whatever the output text which the AI has generated it. Okay, at the end you will have a separator line. At the end it's a separator line where it says with this the content is completed. So it will print something like this, everyone. Date time dot now means it will just say like time right now, like let's say 2025, and it will say 9, and then it will say 14, and then what's the current time, like 9:45, it will register like this. Okay, then it will say patient. Okay, then it will say your name. Okay, you can just say XYZ, and then you can put your ID. Your ID is, let's say, 123, something like this. Then your input is, let's say you would have said that, hey, I have some chest pain, or I have trouble breathing. You can provide that, and then output is nothing but whatever the Google Gemini has given as a response, AI generated response. This is all gonna be saved in a document. That is what. And the document name here I'm mentioning, multi-agent conversation log.txt. In this document, it will be registered. Okay, so here is the file. A new file will be created with all the details. With all the details, a new file will be created, and that file will be called as the multi-agent conversation log.txt, everyone. Okay, and that is something which will be added to the end of your file. Okay, where you are going to log the entry, and you will be able to add. So now, before it gets registered, right, it will ask you your name. That you have to provide your name, you need to provide your patient ID, you need to provide your user input. These are the three things which the user has to provide. These are the three things which the user has to provide, everyone. One being the name, another one being your patient ID, and the third one being your user input. These are the three things which you need to provide from your end. And based on these details, a logger agent will go ahead and will log everything in a document, and it will create a document called as the multi-agent conversation log.txt. You can provide whatever the name you want, that's absolutely up to you all, but this is the main idea is what we need to go ahead with. Okay, so ultimately that's the point which I just want to highlight. Now, as you got to know, that as these topics are being completed, so finally, what you need to do, you have to give all the input, whatever is required, the input like name, ID, and then the user input. And after which, you see that in this scenario, here is where your agents will run. Here is where you see that your agents are going to run. Ultimately, what is happening? If you observe, symptom agent, which we created at the top, the symptom agent will read what the patient wrote, the user input. Like, let's say I have a chest pain. Then it will ask your Gemini, how serious is this problem? Okay, then there is a scheduler agent. Now the scheduler agent will go ahead, look at the Gemini's analysis, and then it will provide a summary. Okay, based on what the patient has asked, I would just go ahead and create a summary so that it can be helpful for us to see the details. Then there is a follow-up agent. Follow-up agent will ask what extra questions I need to ask so that I can understand the things in a better manner as a nurse. Okay, and then finally there is a logger agent. Logger agent will try to log all the conversation. It will try to save everything, your name, your patient ID, your user input, your summary, and then what are the next steps we have been said, and if there are any follow-ups, everything will be registered within the document. So basically, what are we trying to do here is, these are the multiple 4 agents we are trying to use. One is understanding the symptom from the user. Second one tells what to do as the next step. Third one says like what more questions I need to ask in order to analyze the particular health symptom or the problem in a very clear way. And finally, saving everything in the file. Okay, finally saving everything within the file. That's it. Okay, this is your entire multi-AI agent, everyone. So this is your entire code with which you should be aware about. Again, I'm trying to let you all know in this scenario. So first we are installing the Google Generative AI. I mean, these are all prerequisites, everyone. Okay, you see that here, these are all your prerequisites. You are getting whatever is required. Okay, you are importing the file system within the Python library, and then you are importing the date time where it will register the current time, and then you are calling the google.generative AI and putting a short name called as a GenAI. You are putting your API key to configure so that you can validate and authenticate with your Google Gemini, and we are mentioning that what Gemini model we want to use. So we are highlighting that here it is Gemini 1.5 Flash, latest model I want to use. Okay, then here you are defining a symptom agent in this scenario, everyone, where you are saying that I need to provide an input, like what exactly is the symptom I have with me. Then you are saying to the AI model that, hey, classify the severity of the symptom, whatever the user is been providing as an input. Then print that response to me and return that response so that you can use this return for other agents to help them out. Then you have a scheduler agent. Scheduler agent will look at the severity summary, whatever has been fetched by the symptom agent. Okay, based on that summary, it will suggest you the next steps. Okay, it will go ahead and will provide you the what are the next steps you need to work upon. Okay, so that will be present in your based on the symptom severity summary. It will suggest what are the next steps we need to take up, and it will also print the response. What are the next steps you need to do, and it will return the result over here, everyone. Okay, it will be able to return the result whatever we require. Okay, then you see there is a follow-up agent. Now follow-up agent will just try to check what questions further I can be able to ask based on the condition which you are facing. So those questions will be able to come up as a follow-up agent where it will print the response and you can see them. And then finally you have a logger agent here, everyone. Okay, logger agent, why I require? So the very purpose of the logger agent which I need here is, so whenever I need a logger agent, the very purpose of having the logger agent in this scenario is to record your information. So it will provide the information, like first it will capture the time that when it is logging the records, the patient name, the patient ID, what is the input text, that is the problem which you provided, and what is the summary which the AI was able to generate. And it will create a file called as the multi-agent conversation log.txt. You can create any file whatever you want. It will log all your entry whatever we discussed. But before it logs the entry, it will ask you to provide your name, your patient ID, and then the health symptom whatever you are facing. And then finally these are your agents, the 4 agents where the execution is going to occur. Okay, so the first agent will try to make sure that it will give you the chance to provide the input. First it will analyze what is the symptom you are facing. Then as a scheduler agent, it will try to give you the summary. Then again the follow-up questions, and then finally a file will be created with all the details which the agents were been able to capture. That is your name, your ID, your user input, the summary, the next steps what you need to follow, and if there are any follow-ups, it will be able to give that information. So let me go ahead and execute this once. Let's try to execute and see based on whatever we have understood. So first it is asking me, hey, enter your name, who you are. Okay, let me say my name is Prashant. Let's put that. Now click on enter. Then it says what is your patient ID? 123. Click on enter. Now it is asking, hey, describe your health symptoms. Let's say I have a health symptom which is, I can put the same thing, right? Let's say chest pain, something like this. Okay, let me add it. Now see, first it goes to symptom agent. Observe. Right now your symptom agent is analyzing. It went to Google Gemini. It understood my name, my ID, and then the health symptoms. See, first it says chest pain is a symptom that ranges in the severity from mild to life-threatening. Okay, so if you observe over here, first it says, okay, first it went through what agent, symptom agent. So it first goes through a symptom agent here. So I described my chest pain, right? So the agent will say chest pain can be mild or life-threatening. Okay, and it will say possible cases also. Possible cases, okay, it gives you like maybe it's a serious, if it is a serious, right, then it may lead to some heart attack, blood clot, or if it's less serious, it may be muscle strain because of acid reflexity or lung infection. Okay, and it also says to get help immediately if chest pain is very sudden or it is linked with any shortness of breath or dizziness. So it will try to give you all those things. Okay, see, so it will give you where exactly is the pain. Is it central, left-sided, right-sided? Is it sharp? Okay, or is it stabbing to you? It's a burning pressure. Does the pain radiate to the arm, jaw, back, neck, or shoulder? Okay, when did the pain start? Was it sudden or gradual? Okay, the duration. So there are different ranges. Okay, it says here, see, observe. If it is really serious, it may also lead to heart attack, or it may lead to blood clot in the lungs. Okay, it can be anything. It can be dizziness, it can be collapsed lungs, so it can be any problem. So you have to be a little bit more careful. If it is less serious, then it may relate to muscle strain, acid reflux, anxiety, or maybe lung infection, maybe something related to it. Okay. And then after that, it goes to your scheduler agent, the next agent. The scheduler agent says to do next, please go ahead and call the emergency. Okay, and then it also says that to please clearly explain your symptoms, like make sure that you let the doctor know where is your pain exactly, how bad it is it really sharp, okay, do you have any nausea or cough like that. You have to go through all those things. You have any medical history, all these things you have to taken up. Okay, if any medical checks are required, you have to do that, like doctor checkup, ECG, blood test, anything as such. And then based on the test results, doctor will treat you accordingly. It is just saying you all those things, okay? Then as a follow-up agent, see here. As a follow-up agent, it is asking you the questions, everyone. Okay, so it is asking you first, make your questions open-ended, very clarified, specific questions. So see, if it's a specific question, ask where exactly is the pain located. See, tell me about your pain instead of, is your pain really sharp? Okay, then, so it's giving you some patterns like how you need to ask, and then it is giving you the follow-up questions. Can you point it to where the pain is? Can you describe the pain? When did the pain start? How long does it last? On a scale of 1 to 10, how would you rate your pain? What makes this pain better or worse? Does the pain spread everywhere else? Like if you see that, then it is asking everything related to cough, shortness of breath. Then it is asking related to nausea, vomiting or diarrhea, dizziness. So it's giving, is there any previous medication history? Okay, so all those things it's trying to capture. And you see that logger agent. Now, where is the document? Whatever the response it has been able to provide, right? Where is the document present? Like multi-agent conversation. See here. In the Google Colab, we have files. Click on files. If you click on files here, right, you will see that your file is present here. You see that this is my file, multi-agent conversation. And you click on these three dots and say download. Let's try to download this. Okay. And the moment you download it over here, okay, so you see that in this scenario, let's try to open this. Okay, so if you see the moment I go ahead and then try to download or open that, or maybe here also you can see, I think it's trying to bring in, see here everybody. Okay, it took the time, it took the patient input and then the AI summary. Okay, see, input is my chest pain. These are the three things, and then see the AI summary. Whatever the AI was able to give the response, everything got downloaded in a document. See, this is my AI summary, which is being provided. And then it is saying to the wherever you see the lines like this, that means the conversation has been able to get ended. So everything got logged, and you see that the document has also been created where you can go through in detail. And this is a log, like this is a proof for you to validate and see whatever the response you have been able to generate at the end of the day. Okay, so this is how you can create a multi agents where you can have those agents work on different purpose, and they can be able to come up with some great results, and you can be able to see the responses being generated over here, everyone. So what you can do is you can like see that the file also will be downloaded here. There is in the Google Colab files where you can see the file is present, and you can take that file and can be able to leverage it in whatever way it can be. Okay, where it can log all the information and you can see those responses. So what am I going to do right now here is I'll just quickly open a Word document, and we'll be sharing the code to all of you there, and you can download the document from the main chat. Okay, let's go with this blank document. Let's take this entirely. Okay, and then let me try to save this as multi-agent healthcare. Okay, let me save this quickly and share it over the chat to all of you. Okay, so I just shared it to all of you as part of the multi-agent health. Oh my bad, actually this document is open. Before I save it, let me remove my API key and let me save this. Okay, let me save the file. Perfect. I just have shared the file to all of you, everyone. See, what I want you all to do is, okay, now over the week's time, Okay, over the week's time, whatever you have, I would request you to practice the program, whatever I have given to you. Try to use it for different purpose. See, now I gave for healthcare sector, right? You can try to create some small agents, like let's say for your fitness, anything related to, let's say, healthcare domain only, like pharmacy. Okay, so try to customize it, like try to play around and see that how well you can be able to leverage it. And then first what you do is practice the program which I have given to you. First, that is important. Once you practice the program, right, then you take some customization and try to play around with it, everyone. So this is what I just want to explain to you as part of our today's discussion. Today we understood the agentic AI architecture, like where we understood the perception, cognitive, and then the action. Then we understood the single agent architecture. Then we understood the multi-agent architecture. And then we have done a hands-on activity for the single agent, which we learned at the first. And then now we have discussed the multi-agent, where you can create multiple agents and can be able to interact and can get whatever the responses which we want. See, the code is pretty simple, everyone. If you don't know Python, right, that's absolutely fine. The reason is, once you get to know Python, this is going to be very, very simple. And even if you don't know Python, at least if you know the flow of how things are happening, right? Once you keep doing some 2 to 3 programs, fourth program will be a cakewalk for all of you to complete and do it. Okay. That is the best thing in this entire agentic AI, everyone, where we have standard templates and structures. Only thing is, case study to case study, it will differ and you can be able to create the things on its own. Okay. So this is what I just want to cover as part of our today's discussion, everyone. People who are clear with everything, whatever I discussed, people who are clear with all the code, and if you have downloaded the document and if you have everything handy, and if you don't have any questions for me, I would request you to please acknowledge the feedback. If you really like the session, you can please go ahead and can rate it 5. And if you have any comments, you can please let me know. Okay, and if you don't have anything, feel free to drop off. We'll meet again over the next weekend with a lang chain concept. I'll take you to a lang chain. Lang chain is another framework in the world of agentic AI. We'll discuss about that topic once we move to the next session. Okay, thank you, everyone. The people who don't have any questions, please feel free to drop off. Thank you so much for your time. We'll meet again over the next weekend with further topic. Okay, and please keep practicing these programs, whatever we are discussing, so that it will be helpful for you in the upcoming sessions, where we will move into some more advanced topics and will deal with all these things. Okay, thank you, everyone. Great job. Okay, so have a great weekend. We'll meet again in the next session. Meanwhile, remaining people are having questions. Let me try to resolve them quickly. Okay, so we'll go one by one. Quickly, over to you, Mukesh.
Yeah, I have few questions. Like for this program just now, you write for multi-agent. So here we see we have created only one instance for model, and for the same instance we have a multiple methods. So can we
More or less
say this
exactly.
is single agent, yeah, multi-agent? Because one instance with multiple
See,
method.
model will always remain the same. Multi-agent means it's just like you are giving multiple responsibilities for all the agents to work upon. Okay, so it doesn't mean that if you have 3 agents, you have to use 3 different models for it. Model would remain the constant one. Okay, or you can use 2 models, but ultimately you have to integrate it with any one model and can create different responsibilities. That's what I said. Like when we are creating multi-agents, I said when you're creating multiple agents, every agent is going to have a specific role or responsibility which they need to take it up. So you can have one model and can integrate multiple agents to make sure that they work on different activities. That is the main reason behind it. Mukesh. Yeah, please
Okay.
continue.
So the study one, you have written one program there. You show the generate content method you use, and today you show some chat session. So what are the difference between those? What is the scenario
Like
where we should use?
okay, in all your multi AI agents, Mukesh, you have to use chat, because all these are chatbots, right? When you're creating a chatbot, it's a chat. When you're only asking one question, you will say generate a content. Both mean the same. You can also interchange here and play around. Still, it will give you the result. But here, as it is more related to chatbot, we just said that generate a chat over here. or maybe when we said that create a chat and then try to give the result to us. That's the only difference. And you can play around interchangeably. These are like different terminologies we are using to go ahead and start the conversation. That's it. That's the major idea in this scenario. Okay.
Okay. Okay.
Yeah.
Thank you.
Just you have to play around interchangeably, Mukesh. It doesn't mean that just because I have used in my first program generate content, I cannot be able to leverage it here. You can still do it here also. Or you can also say start the chat and it will be able to go ahead and provide you all the information related to it. Okay? Just you can play around interchangeably and can leverage.
And yeah, and I have one last question. So in my company, they provided a co-pilot license, and I tried already all the DeepSeek, Cloudy, and all those, but I don't have sufficient balance there, so I'm still relying on Gemini. But in my company, if I'm going to create one custom agent and with a co-pilot license, so on how
It's
we
the
have to
Copilot
do
API
that?
key. You have to use just here the Copilot API key. Okay. So what you need to do in that scenario is you will just be able to go ahead, whatever API key which you have for the Copilot, whatever you are using, right? So you need to get that Copilot API key. The moment they provide you the Copilot API key, instead of using the Gemini API key, you will be able to use the Copilot API key in that scenario. And what you have to do, so when you are using Copilot, okay, you have to just simply say something like this. 1 minute. This is how you have to say. So let's say you have to say import. Okay. Import like
Okay.
Copilot is again a product of OpenAI only. Okay, you
OpenAI.
can say import OpenAI, and then you say here something like OpenAI dot okay API underscore key, and then you provide your key here. That's it. You don't need anything related to Google. So here is where you will provide your API key and whatever model you want. Like instead of model whatever we are using there, Gemini 1.5 Flash and all, here you will use your model as let's say GPT 4 or a GPT 5, whatever you want. That's it. This is the configuration you are going to provide it instead of Google.
Yeah, yeah. The question here is basically inside Copilot, still they are calling any OpenAI model like GPT-4, 5, anything, right? So, but in our program right now, we are creating a API key for those models, right? So, how it relates Copilot and LLMs?
Copilot is itself a LLM, right? You are just saying that in the Copilot, whatever model is residing, you are trying to call that model in your program. API key is only for you to validate. Like it will understand who is Mukesh. It will understand that, okay, this API key belongs to Mukesh, then Copilot will say, okay, I will allow Mukesh to enter into the Copilot. After that, it will allow you to enter into whatever the model you have been mentioned over here. It's just an authentication mechanism, API key. Once you provide your API key as an authentication to validate whether you are the right user or not, then it will ask you to what model you have to use. So you're defining that model as GPT-5 or 4, whatever is available in your Copilot, in your organization. That is the only thing which we require. After that, logic and everything still remains the same, whatever we are using it.
Okay, let me try something.
Yeah,
Yeah,
try
thank you.
and let me know in the next session. That's not a problem.
Okay, thank you
Thank
very
you.
much.
Over to you, Vinay.
Hi, Prashant. I have three questions. Like yesterday, tried with the program whatever you have given. In that one, each time I'm seeing the response time will be same, like 4 to 5 seconds. It is giving me the response time. So will it not be used any cache for giving the response? Like I am giving the same question multiple times. It is
Correct,
taking
correct.
the same time.
Exactly. So the thing is, when whatever we are using, right, those models are free actually. They take some time, like some good amount of time. So those are all the Flash models and all. Those are little older models. We are using version 1.5 today. Gemini using the Flash model 2.5. So these are older versions, na? So they are free of cost. All these AI API keys which we are using is for demo purpose only. When you use an advanced model, you will not face these type of problems, Vinay.
Okay, okay. And yesterday we didn't install that Gen AI before, like just imported that Gen AI. We are not installed, but today we have installed. What's the difference, like installing and
Nothing.
just
Like
importing?
if you have done installation one time, right? I have explained it in multiple programs. What happens is Yesterday, whatever the model which we were been using or the approach was very simple. So today, why we installed this Google generative AI is because we will use it in agents, right? So it's a one-time installation only. So let's say if you have already installed it, what I did in my previous programs, I've already installed it. Okay. So already Google Colab also has the Google generative AI. So what you can do is, Vinay, like for an example, when you execute it, you can remove this. If it is already there, then your program will run successfully. But if it is not there, it will call out saying that, hey, you don't have the Google generative AI, how are you going to run? In order to get rid of that problem only, I installed it. Let's say for a minute you remove this and then try to run it. If it is running, that means already it is installed in your system. If it is not installed, then you need that command to install it. That is the reason I explained it as an additional purpose for all of you to know how to install it. That's it. It doesn't have any other significance. If it is already installed, you don't need to install it again and you can run directly
Okay.
from your import part itself. Okay.
Fine.
Thank you.
And one more question, like in this open AI, you told just hello.
Go ahead. I'm taking up still further your question.
Yeah, yeah.
Uh,
That open AI, just now you told the other guy, like for Mukesh, can I use the same open AI in Google Colab?
Anything you can use it in Google Colab. I'm taking an example of Google Gemini because that's a free of cost. OpenAI, you have to pay for API key. Otherwise, you can use OpenAI, you can use Grok, you can use Copilot. Copilot is nothing but again OpenAI only. You can use the Gemini, what we are doing. We can integrate with any of them. That's not a problem. Okay? You can use anything in the Google Colab. It supports everything, not only for Google Gemini. Okay?
Okay, thank you.
Cool. Yeah, thank you. I've just asked one of you to unmute who it was. I think Satya. I think Satya is not here. Okay. Tanvir?
Hey, hi Prashant, can you hear me?
Yes, I can hear you, Tanvir.
Prashant, for the question is first program single agent. The symptom first time I gave my stomach pain, so it's giving serious condition. Second time I gave sneezing, so again it's giving serious condition.
Okay. It's all because of the lack of model awareness, I think. That's the only problem. See, we are using little older models now, so that is the reason it is not able to identify it appropriately. I will try, okay, just try to check it out. What are the different models available in Google Gemini and take one of the latest model and then try to play around and see if it is giving or not. And one more thing, Tanvir, I'll just request you to please refresh it one more time, the Google Colab, and execute and check still further the output, whether if it is still giving the same or not. Okay, just it's a play with the model actually. Whatever model we are using, if it is a little older model, right, it will further hallucinate because all this is a free AI models which we are using, right? That is the reason.
Sure, I will try. And second question is like a second multi-agent program. We are giving the patient ID. So how user as a patient will get the patient ID? Generally, when we admit in a hospital, then we will get some kind of ID, right?
Correct.
So how you patient will give the
This is
name,
a post
the
analysis.
patient ID?
Post analysis, Tanvir. It's a post analysis. Let's say you already got added to the hospital, you already have the patient ID associated with it. You can always use the patient ID and can ask for health symptom. So it's something like where you already are there. So it's not like let's say if you think the second scenario, I did not admit to the hospital itself. Why I need patient ID? Then remove that from your code. That's also the right point, right? Let's say I did not admit to the hospital. Why you need a patient ID? Then put your name and put your health symptom. Remove the patient ID from the code, if that makes logically
Got it.
sense.
Got it. Got it.
That's
Thanks, Prashant. Thank you.
Tanvir. Over to you, Vaibhav.
Hey, am I audible?
Yes, you're audible.
Okay, perfect. So I'm just extending the question which Chaha has. So why we are calling it multi-agent and not multiple prompts? But because these are the sequential prompts only, correct? It waits for one prompt to finish, give it that output, and again give it to the next one. It's going in a sequential. It's not going in parallel. Our multi-agent example, because it's waiting for response from one to revert, correct? So why not
Yes,
to call
absolutely.
it multiple prompt instead of calling it multiple
It's
agent?
up to us, Vaibhav. If you understood it in that way, you can call it in that manner. See, why the
Hmm.
world wants to refer to it as a multi-agent is every of them, see, it's like at the end of the day, everything is a prompt only, right? At the end of the day, everything is a prompt. Either you give instruction, until you don't give the instruction, it cannot do anything. Any AI agent in the world you want to do, that is a instructions, right? Now you are giving instructions for it to do. Now let's say you write a program. In a program, what we do? We write instructions. This is how the logic should work, and it should be able to help the end users. This is what is happening in the agent. Like you are creating three agents. Three agents are nothing but three responsibilities. In those responsibilities, you're giving the instruction in the form of a prompt, so that it is able to go ahead and sequentially go ahead and do that activity as you rightly summed it up over here. However, we want to correlate and call, that's absolutely fine. But that is how the multi AI agents are going to collectively work upon and get the information for us, Vaibhav.
Okay,
Okay.
because the same, if I give it the same prompt in a single one, that I want, I have this disease, give me the symptoms and help me with follow up. Even in that case, also
Absolutely.
all three will
It'll
be
do.
available. Correct?
It'll do. Correct, it'll do.
Yeah.
But only thing is the way there, the effective output, what you are going to get, and the way how you're going to create with the agent, do some similarity, comparative analysis, and then check it out, like how the result is going to come. Then you yourself will understand that how agent will structurally give the response and how a normal prompt would actually give the response. I mean, in that way, you'll have a better comparative analysis, Vaibhav.
Okay, so in case what we have done is sequential. If I want to do asynchronous, all three of them, so what the change we need
We'll
to
do
do?
that further. Yeah, we'll do that
Oh,
further. Yeah,
okay.
we just started the multi-agent today only, na? So we'll
Mhm.
do a lot of different things related to it. Okay, gradually you'll get a broader exposure towards this side.
Okay, then we'll wait for. Thank you.
No problem. Thank you, Vibha. Over to you, Trisha.
Hi, Prashant. Am I audible?
Yeah, now you're audible. Perfect.
Okay, thank God.
Go ahead. Yeah,
So,
no
my
problem.
first question is when you have
Mhm.
mentioned in the codes, you have mentioned three agents where you have taken the model, which is basically Gemini model, which is a LLM model, right? So, you have mentioned that in the agentic AI, you have three different layers, which is the perception layer and cognitive and action layer. So, where I am mentioning these things in the model, I mean, I want to understand,
Perception.
is it
Okay,
that,
perception layer. Perception layer is the input what you provide. Okay, the input, that's health symptom. Got
okay,
it?
so, okay,
That is
got
a
it. So,
health
this is
symptom.
not a transformer based architecture, no layer is there in the
No.
perception.
This is not a transformer based architecture. Transformer based architecture is present in the within your LLM. What we are learning is the agentic AI architecture. Okay?
So when you are saying these three layers are the additional of the LLM architecture, which is basically transformer-based architecture, right? And when you have mentioned in the code model dot generate output, so these are
Mm.
something you are taking the inputs, right?
Correct. Exactly. That's right. So here, your agent is present, Trisha. Okay? This is your agent. Your agent AI or agentic AI is a separate part. Your LLM is a separate part. It has a transformer architecture. Now, as agentic AI does not have intelligence, we are integrating this with your LLM here. Okay. Now, agentic AI architecture has your perception, has your cognitive, has your action.
Correct.
Okay. That's it. This is
So
separate.
what is
This is
at the back
separate.
end of perception layer? It's just
The
the
back
input.
end of the perception. Yeah, it's an input. Yeah, it's an input what you provided. The
And
back
what
end
is
of
at
the
the
cognitive. Mhm. Go ahead.
and so what is at the back end of cognitive layer?
Cognitive is a decision. It's a decision making skills. Like means what decision, this is where it takes the support of the LLM. When it is coming up with the decision, it uses the intelligence of the LLM. That is the reason we are integrating it with the API key. After it gets the help of the LLM to take the decision, finally it gives the action to you in the form of an output. That what you actually need to do.
So when we are saying cognitive, it means that it is taking integrating the LLM, which is my transformer based
Exactly.
architecture. So
That is where it taking the help of the transformer based architecture, which is your LLM.
okay, so that's why when you have used the code, we don't need to mention anything apart
Correct.
from, yeah. Okay,
Correct.
so got it. So one more question: when you have created this chatbot, even
Mm,
I have used the other models also in LLM. How
mm,
will I
mm.
validate that these models are working fine? Because in ML we used to have the different classification and performance metrics. If I don't want to use any human involvement, just to check the log, my logs are working fine or not, then how will I evaluate that my chatbots are working
In,
fine?
in agentic AI, you need to do a comparative analysis, like where you integrate first one with one of the model like Gemini 1.5 or Gemini 2.5 Flash model, then take up another model in the let's say OpenAI using GPT-5, do the comparative analysis of the results, whatever it is trying to provide, see how well and effectively it is being able to provide the output, and then you need to assess and validate it. Okay, or otherwise, another option is you have something called as a Lang-Smith. You can also use Lang-Smith, and you can also see that how in terms of performance. But that performance is more like what do we call, like who has the highest tokenization, who have the highest capacity in terms of generating the output. That's more related to performance. But if you want to analyze the output, you don't have anything as how machine learning has a classification or a logistic or a regression classification analysis, right? Those type of things are, at least at this point of time, is not available in agentic AI, because agentic AI is still being new to the market. Maybe in the further updates we may get it, but currently it's the comparative analysis only what we need to do here, Vishal.
But doing the comparative analysis with different models when we have the different LLMs is will be very hectic, right? So, is there something like precision at K or something that I can use, or
No,
maybe
no, no.
anything else?
No, we don't have it. Only thing what we have to do is use the existing machine learning concepts onto it, find out the top K score or confidence score, and then you have to move ahead with. Whichever is giving a high confidence score, by integrating with LLM, you can pick up that particular response and move ahead with.
So it
That
will be
is the
more
only
like dip and
options which
try.
are available. Sorry?
Okay, okay, got it. And one more last question, just you have used three different agents here. You have created three different agents. If I want to add more agent, so in that case, how will I scale up? I will just create agent 4 and 5 before
Yeah,
logger agent,
yeah,
right?
correct. Create of Python functions, provide the right instruction what you want that agent to do. You can scale up multiple agents and can take it further also.
Okay, got it. All right, sure. Thank you.
Thank you. Yeah. Over to you, Bagesh.
Hi, Prasan. See, that is related to memory. Okay. Basically, as you said, that is LLM using for vectors database. Okay. So already we are using for scalable and NoSQL database like Hedgebase and data warehouse, Hive, those kind of things. Still, we can use it for memory perspective.
Yes, we can use it.
Okay, so only we need to download this MLM
Correct.
API and
Ah,
call that those database, right?
absolutely. That's it. That's
Yeah,
the only
okay.
thing which we'll be doing it. Yeah.
Yeah, got it. Thank you.
Perfect. Thank you. Over to you, Pradeep.
Thank you, sir. Sir, can you just go back to that code which you have written? Because I have two questions in that. I mean, very quick questions. If you
Quick.
can, just can you go down bit? Just a moment. Sorry, between 1 and 2. Sorry, 1 and 2. Just upstairs.
Between agent 1 and 2.
Yeah. Okay, fine. So, when we say that we are defining a function, for the user input, okay, we are doing that. Then in the second one, scheduler agent. Now, how does two agent relate to each other? Because see, as per my limited understanding with Python, because as I said from non-technical background, so there's no some correlation, because the first function is says input text, and second one something you're saying based on the summaries, suggest symptoms similar. So how does that both interact with each other?
Very right question, Pradeep. See, actually, as for Python, when it will correlate when you use the function directly. Let's say I use
Yes.
symptom agent. If I use the symptom agent, anything over here, that makes a direct correlation here. Correct?
Absolutely.
That's
Yeah.
the right one.
That's
But
point my
now,
doubt was actually. Yeah.
exactly. So now, whatever return you are trying to do here, this is AI models. They are all know very much how they are correlated. When you return this response dot text, okay, now this will automatically be correlated to your agent 2, and agent 2, whatever symptoms like symptom severity summary, whatever is present, right, it is going to pick nothing but this response only. Just we are providing a different name here. Whatever the return is coming here, that return will sit here. That whatever the input you have given, that will be sitting here. Instead what you do to make your understanding simple, instead of saying symptom severity summary, put it here in the bracket input text.
Yeah.
It is nothing but the input text what you provided here. Okay. Then you will understand and correlate in a better way that, okay, this is the text what I given here is being considered in this scenario. It's just the terminology, but otherwise, this is how it's a cycle it is going to work, Pradeep.
that makes very clear. Thank you so much. And second question, just since now this agent one, agent two, and agent three, once we execute this, okay. Now in every step, there is some input which needs to be shared. Okay, let's say first input,
Correct.
the user will share the input, but second, third one
Correct.
follow up part. Okay,
Yeah.
is it like
Yeah.
the LLM it's interacting with it intelligently is trying to retrieve all this information without any,
Exactly.
yeah, is it?
Without it. Yeah. Without any. Just complete that one. Without any what?
Without any manual intervention, basically, there's nothing,
Yeah,
right?
yeah, yeah. Exactly. That's it. That's it. Instead of you doing one by one, and doing, write the agents, leave it. It will execute, and everything will be taken care by LLM intelligence, and will give you the final response to you. You don't need to sit and do everything. One agent create and leave it. It will keep on doing everything for you, like gradually whatever we require. That's it.
Okay, last question.
Okay.
So, sir, can you provide me one website address where probably I was trying to search yesterday about the different generative model, let's say Flash model, all those stuff. So I could not I mean get those details in the
Uh,
website.
Basically, you have to go to the Google Gemini official documentation. Okay,
Okay.
they will give you all this information. Let's say,
Oh.
okay, Google Gemini. You can go here. This is an application
Maybe.
here. Okay, you can use this official documentation, and you need to go through it. See here. See the models. First one only is the model. See.
Oh, brilliant, brilliant. Got it. No problem.
Is
Thank
the
you so
model.
much, sir. Thank you.
Share the
Thank
link.
you.
No problem.
Makes sense. Yeah. Thank you. Great.
Thank you, Pradeep. Over to you, Harshvardhan. Okay, I think these are all the previous questions. I think you all have raised the hands. Mm, 1 minute. Let me check quickly. Yeah, over to you. Let's say, actually, we are very out of time, everyone. I have to quickly complete it. Yeah, over to you, Kartikesh.
Yeah, good morning. So yesterday I joined today itself. So can you say the code because everything is in chat, so we are unable to get that code. So can you help me the code or where you are giving any Git repo or how it will be?
Yesterday code. Hey, anyone can you all have yesterday's code? Yeah, I know yesterday's code actually. I need to
Because
search.
it is in chat, correct? So I'm unable to find it.
No, I know. That's not your problem. Agreed. I mean, I
So can you
understand.
create some GitHub somewhere it will be because someone not joined. So any
Uh-huh.
by recording also they
That's
can.
okay. Right. Yeah. We can have
It
it.
will be really helpful.
So I'll try to fetch that code yesterday, whatever we worked upon, and we'll be sharing that to you. Okay. So maybe I'll just put it in the what we call in our Edureka LMS portal, and you can access.
And second one, I took Gemini 5 like Go, correct? We have Indian version. So the API I'm trying earlier, I'm just using GPT 4.0 mini, and I'm able to execute. And after that, like token some limitations crossed, and I purchased Gemini 5 Go, and still I'm using. So same key will be used, correct? Like as you said, like API key will be same to connect and
Correct.
so okay, but it's not giving some error, different errors. If I'm using Gemini 5, what exactly can you?
Change the model. Change the model to lower models. It can work for you. Okay.
Okay, so
Gemini
how can I, yeah, how can I know which one is free and which one is like Gemini? You said all the model will be free.
official documentation.
Oh, okay, okay.
Gemini official documentation, which I shown right now to Pradeep, right? Same thing you can use it. That's where the details will be available. Okay.
Thank you very much. Please send me the code. It will be really helpful.
Yeah, it will be there in the LMS portal. I'll upload there. You can take it from there. Okay.
Thank you very much. Yeah.
Thank you. Thank you, Kartikeshwar. Okay. Dhimant, quickly. Hey, we don't have time.
Yes, sir. So the follow-up question to Pradeep, what he has asked today, can you go to the same code between agent 1 and agent 2?
Go ahead.
Okay, so you just mentioned that agent 1 response will be directly taken to agent 2. This is, I think, only for the definition, right? These are the definition of the functions. So in the bottom, we are clearly executing the functions. So I think I'm just trying to answer to Pradeep. Can you go down,
Go ahead.
Professor? Because what you said is directly it is taking, but here we are clearly giving the summary. I mean summary inside next step functions. For the agent 2, we are giving scheduler underscore agent inside summary we are giving, right?
Correct. Yes,
So
exactly.
here we are calling. It is not from the definitions, right?
No, definition is just the mapping. Here is where we
Yes.
call.
Yes, yes. So, just want to clarify myself if my understanding is correct or
Oh,
not.
yeah. This is where we call them ultimately.
Okay.
The definitions we are mapping them. Okay.
Okay, and one more question what I want to ask is my company is using its own model. I don't know which model it is. So first I will try to ask them which model it is and whether
Yes,
company wise they will. Yes, sir.
and I'll be able to assist you. Okay, we have still 10 more sessions, right? We can assist you, but once you get that model, I'll help you what you need to do.
Okay, whether companies will allow us to plug in or get the APIs. All the companies will they allow? I am not sure. Confidential.
Most of the companies they don't allow because they don't want this liberty to everybody where they will charge because every API will be charged for them. Okay, only the relevant developers only will be given the chance. But again, you can try once.
Okay, I will try to discuss with my company. Okay.
Thank you.
Thank you.
Last question for today, everyone. Over to you, Manoj.
Hello, sir. Uh, Here we create three functions in Python. So to verify what the summary or what the response getting from LLM, so for that we create our separate custom function and provide some information which is I required for my output. So how we will compare this two functions, means summary and our exact similar data, and how we can compare this thing and generate exact result what I want. Can we do this thing?
If you want it, why you need to again create a function? Use the latest version, use the latest model, which can give you the best results.
No, but that LLM give us the information
Yeah.
about what he know about that. But I want exact information from what LLM response give it. So
I'll
how
tell you
we?
one thing.
Yeah.
Function. You ask whom? LLM only. Whether whatever it is giving is accurate or not, you ask. So the same LLM only.
Hello. Sorry, I can't hear you properly.
Got it?
Prashant, can you repeat again because I lost
No,
your
I'm
voice.
asking whatever the validation you want to do, you will do that with the LLM only, right? So do you think that the LLM will say that I'm not giving the right response? It will indeed say that, hey, the response, whatever is being provided is great. That is what I said. I think as Trisha was asking, to do comparative analysis, you need machine learning concepts like top K or score or confidence. That will let you know how much confidence with these LLMs are giving the responses to you, which is a very core advanced topic which we have to take. If writing a function will not help here. Writing a function will also go to LLM only, and LLM will definitely say that I'm giving best answer. Why would it say that it is not? I'm not giving a appropriate or right answer there. So to understand how well it is giving, it's a machine learning concept where you need to do the top K score, and then you need to identify like how much confidence with which it is giving the response to us.
Okay, so if I want to get accurate answer, I need to prepare that type of LLM.
Again, make it very clear.
Yeah.
To understand the response, like how it is giving accurately, use the machine learning.
Okay.
There's a difference between both of them. Okay, that's the reason.
Okay. Yeah. Thanks.
Okay then. Thank you, Manoj. Okay, with this, we are done with all the questions, everyone. I already extended more than half an hour of a session, so I cannot be able to exceed more than this, everyone. How much ever I can answer, I was able to answer. Remaining, if there are any questions, you can let me know in the upcoming session. I'll be able to guide you all accordingly. And you can also send it to Edureka team. If there are any further follow-up questions, I'll be able to assist you. If not, you can wait for the next weekend and I'll be able to guide you accordingly there. And thank you once again, everyone, for all your time for doing these programs and asking questions. We'll take it up in the next session, the remaining topics and then the remaining discussion. And I would request you to please acknowledge the feedback form. So as if you really like the session and if you really think that your questions were been answered, please go ahead and can rate it 5 or excellent. And you can please provide your valuable comments. Okay. Bye-bye and take care, everyone. Have a great weekend. I said have a great week. We will meet over the next weekend with further topics. Bye-bye and take care.